leave this morning. We're number 5. Well, welcome to our final day together, at least for this part of the training. We ended yesterday looking at this idea of what comes pretty quickly after kids begin to make some sense out of fractions with equal sharing problems. And so we saw that there are 2 other problem types, the multiplication and the other kind of division, measurement division, that we can fold into our instruction pretty quickly along with continuing equal sharing. And we began to look at how kids solve these multiplication, measurement, division problems when we're talking about groups of a fractional amount. So in multiplication, kids are solving these problems about groups of 1/5 or 3/5 or 2/4 or 1 1/2 or 2 3/7. And in measurement division, they're still dealing with a fractional group, but instead of building fractional groups and figuring out the total, what are they doing with that fractional group in a measurement division? They're taking it out. It's like that idea of repeated subtraction. So now I'm starting with a whole number and I'm finding out how many of that fractional amount fits in there. So it's kind of it's that inverse idea. Multiplication, I'm building fractional groups, a whole number of fractional groups, and trying to find out the total. And in measurement division, I start with the total, and I try and figure out how many of that size fractional group I can pull out of there. And the easiest problems, I'm going to be building whole numbers of groups of fractions, 12 groups, 15 groups. Later on, you can begin when the kids are ready to have them think about how much would 12 1/2 groups of 6/8 be. 6/8 is kind of a nice one. Why? If you're building 12 1/2 groups of 6/8, you're going to have 12 groups of 6/8 and half of a group of 6/8, which is 3/8. So we can even make our numbers then be more in line with what the kids know. It's a little harder to build 4 1/2 groups of 3/5. I'm going to have to know a little bit of equivalence to name it. It's not, I can solve it with a picture, but to name it, it's going to be, we can deal with equivalence. So we started yesterday looking at this idea of the power of putting a unit fraction as the fractional amount in each group. And so we saw kids solving multiplication and measurement division problems using a fractional size of 1/2, 1/4, 1/5, 1/3, and how that can consolidate the understanding of these fundamental big ideas about that they're coming out of equal sharing with. And it's going to lay the groundwork for the next kind of set of numbers where it's not a unit fraction anymore. And what we see is kids that have more opportunity to solve the ones with unit fractions, their strategies are more sophisticated later on when it becomes 2/3 or 3/4 or 5/9. And we'll see that. We'll get to watch the kids and think about how the work with unit fractions is so powerful to think about when it's not a unit fraction. How can I still use that? So we're going to start this morning. So we're going to finish off a little bit of the unit fraction. We have a couple more kids to watch. And then we're going to lay out the strategies. So we had the strategies for equal share. If you remember, we were looking at how kids were thinking about the numbers in the problem, which were eventually going to be the relationship of the fraction. And we saw the non-anticipatory, no relationship. They were just sharing. Emergent anticipatory began to see the relationship and began to plan ahead the cuts that they were making based on the numbers that were going to end up in the fraction. But those were both direct modeling. And then we had that anticipatory where now it's just a mental model. That understanding was now a mental model. So different strategies when we begin to multiply and divide, when we begin to operate with fractions. Because we're not looking at how they're understanding the fraction necessarily, not the relationship between the two numbers, but we're looking more at the idea of how they're thinking about the whole as a referent unit. And so if you, I know there's some primary or used to be primary teachers in here. It's kind of akin to what place value is all about. So in place value, the kids have to be able to see 10 or 10 as a referent unit, meaning simultaneously they can, I need my two hands for this. They can see this, simultaneously they see this and this simultaneously. And that's a huge idea to be able to operate on a group of something. So the same thing's happening here. They simultaneously need to see 1/5 and 5/5 and be able to think about them simultaneously to solve these problems. Later when it gets a little harder, like the 3/4, they're simultaneously having to see 4/4, 1/4, 1/4 being a part of 3/4, 3/4 being a part of 4/4, 1/4 being a part of 4/4. So a lot of relationships that they have to deal with and keep in their heads. No wonder they're going to direct model for a while, because the relationships aren't obvious yet, or they're tougher relationships. So the direct modeling happens for a while as they're making sense of this stuff, and as they're struggling, trying to understand what's going on here. So we're going to start with Matthew this morning. And he's going to solve a problem. Oh, if you'll get your sheets out from yesterday. So we saw Sarah, Rosie, Maddie, and Divine yesterday. So Matthew's going to be our next little guy. So check with a neighbor and make sure that you both agree on what kind of problem type, partitive division, measurement division, or multiplication that Matthew is going to be solving.
It's one of the kids' names or something?
Everybody have it? I'll give you a little more time.
We're visual learners. Can you show us?
Oh, I sure can. Can I borrow yours? Yeah, it's this guy. The front of it looks like this. Maddie, Sarah, Divine, and Rose. Well, you'd like to see it though. Looks like that. And it's two-sided, so front side's got Maddie, Sarah, Divine, and Rosie. Back side has Matthew and Brian. Okay, good?
So you have more?
I probably do somewhere, but we've been moving, so I'm not sure where my extras are. So just grab a piece of paper and take notes on that. Does anybody have an extra? Was there any extras laying around?
I don't know what it is.
So we're on the hunt for extras. So what type of problem is Matthew solving? Measurement division, and people think about it in different ways. How do you know it's measurement division? What are some ways you're trying to remember these problem types?
You're measuring what you're taking away each time.
You're measuring what he's taking away each time. You're trying to figure out how many 1/10 each day comes out of 3 1/10.
Are others thinking about it that way? That you're physically seeing the problem that he's solving as measuring or taking away this amount of 1/10? And you're going to keep doing that. Yesterday we saw that if you just do it once, what kind of problem type is it? Subtraction. But if you keep doing it until you can't do it any longer, it's It's multiple groups measurement division if there's no leftover, and it's a little bit harder if there is leftover. Okay. So a couple of you have asked during the week, so I just want to mention it here, and I'll try and bring it up again later. Lots of our kids still could use some work with base 10, with place value. This kind of problem, and multiplication in particular, will help build that. Because this problem that Matthew's solving for us is a place value problem. Why? Yeah, it's a base 10 fraction. So because of the special kind of fraction it is, it's a place value kind of problem. So he's pulling out 1/10. Multiplication also does that. So we'll take a look at those two, maybe a little bit more about place value as well. So again, as we watch Matthew, we're going to attend to the details of his strategy. What did he do? That's the first place to start. Do we understand what he did? And then interpret what understanding he's displayed through his strategy. And then maybe we'll think about responding a little bit too.
All right. So you want to read this story?
Okay. Miss Rodriguez is make 10 pizzas for the class. She put 3/4 of a cup of pineapple on each pizza. How much pineapple did she use?
Can you understand the story?
Mm-hmm.
Okay, so we can let us all. And you want to go ahead and read that story about us?
An animal with a pet store eats 1/10 pounds of food each day. How many days will it take this animal to eat 3 1/10 pounds of food?
That story makes sense to you? Okay, you want to go about solving it?
Okay. So,
Please. Do you want to write your answer down on your paper? Okay, Matthew, tell us what you did.
so I knew that if you want to have one whole, it will be 10. So if you just multiply 1/10 by 10, it will be one whole. So I did that 3 times, and that's 30 days. And then if you want another 1/10, that's 1 day, so it'll be 31 days.
And where did you get your answers there? Answer 31 there?
Because 10 is 30, and then plus 1/10, 31.
31. Can I ask you just to look at just one of these that you kind of repeated it a few times here? What does this mean in our story? What do those numbers represent in our story?
The pounds of food each day.
Which, tell me more about that.
Alright, so this is a pound 1, this is a pound, and then you multiply by 10 to get one whole, because 10 is 1, and then you keep on doing that, and then you get 3 wholes, and then you add 1/10 would be 3 1/10, and it'll be 31 days.
Great, thank you.
Right, so talk to your tables, make sure everyone understands what he did to solve this problem.
Well, let's just agree. I mean, obviously, this kid is going to have one. He hasn't been coached on this particular question.
So on the chart over there, we have Matthew's strategy. So we saw, even though this is a measurement division problem, and we look back on the other measurement division problems we saw the kids solve, often kids are solving these measurement division problems using what? Multiplication, and we do too. Measurement division begs itself to use multiplication because it's asking how many 25s are in 125. Well, I'm going to think about that as multiplication. How many groups of 25? So kids are naturally using the inverse operation without even kind of knowing it. So the mathematics that says, you know, we want kids to understand the inverse, that multiplication and division are inverses, he's solving a division problem using multiplication. Later we can point that out to him a little bit more as we begin to say, what would the number sentence go, what would we write for the number sentence that would go with the story? 3 1/10 divided by 1/10. But what would we write for the number sentence that he used to solve it is multiplication. So it's kind of nice when you can begin to show it was a division problem and you used multiplication to solve it. So what do you do first?
Figured how much one whole was.
Yeah, so it's that big idea that I'm gonna create wholes, and he knows that 1/10 times 10, and he's thinking about it as 10 groups of 1/10 is one whole.
I just would like to make one comment because it's very close to my heart. Like Carl was mentioning yesterday, like you could do something with Algebra 2, and what you do in lower grades matters a lot. If you think of the inverse operation always that you don't know yet what is the answer and you call it X or unknown, and then you can check your answer by doing something like, yeah, it works because if I do it backwards, that's what it will be. Like I don't know how much is 12 divided by 3, let's call it X. I know that it's a number that if I take it 3 times, I get 12. Then what is it? You can solve it. It has to be 4. And I talked with there was a female mathematician who got a PhD, and she said what turned her into mathematics, she felt for a long time that she had to remember a bunch of things what she was taught, and that was boring. But when she felt that she can argue, she can rationalize in her mind, she can explain to herself why does she know that she is right, that's why she chose mathematics as a career. And she was one of the minority mathematicians, one of the first PhDs, Latina, PhD earning female, excellent mathematician. And she said she just loved that thing. And really, basically, now she knows that it's just the inverse operation. But the same thing with the missing addend. If you think of subtraction, like whatever, 8 minus 5 is 3, how do you know that? What do I need to add to 5 to get the 8? that kind of thing made her like she's in control. She knows what she's doing. It's not just, do I remember right or wrong, but I know how can I check that I am right. And I think in that sense it's really a very important thing in general to see these connections. Sorry, just I will never forget that conversation that she said that's why she became a mathematician. It's 3rd grade when she decided math is cool because now she knows what she's doing.
So that whole idea you guys were talking about, meaning before symbolism. So if we had given Matthew or Divine or Maddie or Rosie or Sarah, pick any of the ones that we've seen, if we had given them the equation 4 3/5 divided by 1/5 equals m, solve for m, they may not have been able to make sense of that. Yeah?
These kids knowing, I mean, it's one thing that they understood the fact that, okay, I need to multiply by 10 to get 1. The fact that they knew that 10 that they wrote down was the groups, how much exposure they had to this prior to getting the problem?
These kind of problem solving? I can talk about most of the kids up here, not everybody. But I can talk about Matthew specifically. His teacher just came to the workshop last summer. Not this summer, but the summer before. And I was in his class about 6 or 7 times. Just being there for an extra pair of ears and eyes for the teacher. I didn't do the lesson, but I would talk to the kids and help her figure out where they were and what to do next. So this is really new to he's in a 5-6 combo. So and we went and videotaped him in the spring. And so some of the kids in his class weren't this far along yet. They only had the traditional rule and they were mixing that up, the invert and multiply kind of thing. But all of them were making sense of these problems in a story. When she gave the equation, not everybody had success, but in a problem, kids were solving them in different ways. So her goal was then to begin to attach the symbolism that was coming out of what they were saying.
So he's seen problems similar to this prior to listening to you.
Yeah, she went back and started implementing some of the stuff that she got very similar training that you guys are doing. So he's had a little bit. Now, some of the other kids, you're going to see Brian next. Brian had a strong 4th grade CGI teacher. She was one of the very first ones that went back to Madison, and she taught 1st, 2nd for a long time, and then 2nd, 3rd, and then she went to 4th. So she brings a lot of experience listening to kids and building on kids' understanding. So Brian has come with a longer amount of time being able to think about some of these ideas. But we see kids will, if you go back in your classes and try some of these, most likely you're going to have a lot of pictures at all the different grade levels. And there may be some kids that begin to use numbers in a kind of beginning way. But probably not very many that will be doing what you'll see Brian do in just a minute. It just takes time and exposure. It's not that Brian has this matching. He's just had the opportunity over lots of problems to develop this deeper understanding. Does that kind of help set this in a context for you? Okay. So we're looking forward. I think Matthew's 5th. I'm hoping he's 5th because I want to go back to his school next year and continue to watch him grow. So what does Matthew understand? I think we kind of said some of it, that he understands that 10 groups of 1/10 is 1. So he's got that understanding of what a unit fraction is and that referent unit of 1, 10/10s being 1. What else? Might be something more subtle that we might miss that he understands. He understands where to find his answer. Yeah, why do I add the 10, the 10, the 10, and I add 1, not 1/10? So he's making sense of these equations and understanding where do I look. It's not after the equal sign that my answer is, not in this one, right? It's not 1 and 1 and 1 and 1/10. He didn't answer 3 and 1/10. So I want to show a little bit of what Matthew's thinking is. If we notate it a little bit more mathematically and the power that kids begin to develop here. So if we look at what Brian was doing, he was trying to find out, Matthew. So they do 1/10 times 10, right? I'm going to flip it just so we can talk a little bit more about groups of 10 groups of 1/10 plus 10 groups of 1/10. This groups of idea really supports kids' understanding. Plus another 10 groups of 1/10 plus one group of 1/10. What's that going to equal? 31 groups of 1/10. So, and we don't have to do this, but it's nice because it helps us focus on particular parts. So what intuitively is Brian using to solve this? What did I do? Oh, thank you. Good thing you guys keep track of what I'm doing up here. Don't you wonder where that 1/4 came from in my brain? Maybe because I wrote 4 of those things up there. Don't you wonder, like, where did that come from? So what is Matthew intuitively using here to solve this? If we write it more formally, he didn't write it in such a formal way. Anybody recognize it? It's a property.
The associative property.
Not the associative. But thank you for bringing that up, because we'll look at the associative in a minute. Distributive property of multiplication over addition. If you say the whole thing, you'll never get it mixed up with associative. Because we have to say the whole thing. The distributive property of multiplication over addition. You're going to see both addition and multiplication, and you're going to know it's distributive. Associative, you don't see both operations. And Brian will help us see that in just a second. So Matthew's pretty ready to be shown this, because he's kind of saying it. So what you mean is you thought about 10 groups of 1/10 plus 10 groups of 1/10 plus 10 groups of 1/10 plus 10 groups of 1/10 is the same as 31 groups of 1/10? Yeah. So again, it's the understanding of what's coming out of kids and what they're writing on the paper that we can begin to translate into something that looks a little more formal. So it's going to look like that on a 9-10-year-old's paper, 8, 9, 10-year-old's paper. But if we show the thinking more not more sophisticated, because that thinking is as sophisticated as this. But if we show it with more, more mathematically symbolic way, we see that kind of thinking is exactly what Matthew's doing.
We don't mean to interrupt too long, but we just wanted to bring a couple things up because of some things that have come to. I had a couple of people come up to me today. So we created our folder that we're sharing all this stuff. Who do we need to share that with, and where do we? So and you've gotten ahead of us a little bit as far as organizing that information. So we're going to get right back in front of you. So we have created, the Google folder that I shared with you the other day that had the calendar in it. Some of you were able to access it, and some of you requested permission because you were trying to access it with your personal Gmail account. In there, we have created a folder that says cohort working folders. Okay? So that all the work you're doing within your lesson study cohorts, you can house in there, because we want our instructors to have access, us to have access, other cohorts to have access to the stuff that you're doing. So within that folder, what we want you to do is create your group's folder. So if you're cohort number 17, you just cohort 17. There's a folder, and you put yourself in it, and you can organize your folder how you want to organize your folder. I just don't want crazy names. put the cohort number so everyone knows what
Funky chickens.
But that way we house everything together. Because of the fact this is research, if at some point the state calls me and asks for information, I don't know if they will, I can just go to one spot. I don't have to try to hunt people down to get what I might need. Where's the evidence that they actually met and did you said they were meeting for 7 hours. What did they do? I can just, there it is. And stuff like that. And,
Jeff, do you want us to put our agendas and meeting notes in there too, or all cool?
what do you think, Carl?
What did they ask?
If their agendas and meeting notes should be in that folder? Or just what they produced?
I think just your actual lesson itself.
Yeah. The stuff that you're working on. Yeah.
The reason why we want to house your lessons in that folder is because we want everybody to have access to everybody's lessons.
Okay. Does that make sense? Okay, so the stuff, the lesson itself. Yeah, if you have problems getting on Google or creating that, let us know. We'll help you, show you how to do it, but we really want you to take ownership of your folder so that every time you want to do something, you don't have to call and say, hey, can you create another of this? And the other thing is, if you've already started a folder, we need you to just move it in there. Okay? And if you need help doing that, let us know. We can help you move it. And then Rob's going to talk. Yeah, the presenters, and we're going to have all the stuff from the intensive week starting to go in there also, so that we have all of our resources together. And then Rob wants to talk to you about
All right.
something.
Just quickly, Mike, reach on like that. I still got to sing when I get this. I'm the bell dog. Just quickly, some things I've been hearing and comments received. How many of you are here today with people from your school at your grade level? So your PLC, you guys are here together. Raise your hand. Okay, put your hands down. How many of you here are by yourself representing your PLC? Okay, yeah. Close to half of you are singletons floating out there. And some of you are going to feel like you're on a dynamic team, that this is going to be, you've got friends to talk to every day, and as you try things, some of you are going to feel like Tom Hanks out on an island and talking to themselves at times. And so I recommend the other group to get a volleyball, slap your ball print on it, call them your friend. But we are your friends. And the beautiful thing about the structure of what we've got going on here is that the cohort structure is set up somewhat geographically, and so you are hopefully near somebody, unless you're an oddball. So that was the one problem. Oh yes, yeah, we did it. Yeah.
Nelson, close.
Sorry, you got a problem. So you're really gonna feel like you're on an island. But the way the grant structure, we touch each other regularly with intensive days, with cohort days, with these student thinking days and follow-ups, and this is not something that we're gonna be living in isolation ever. So you'll have someone to talk to. Now there has been concern that I'm worried about my principal and my GIS, and my peers who may expect something very different from what I'm going to attempt to be doing. I see items, I see units of instruction, I see a textbook, what might you do? Okay. First of all, as far as your administration goes, they all gave permission for you to participate in this program. They knew there was a 3-year program. They knew that you would be participating in shifts in education, in mathematics. They supported that. We are going to have conversations with all 15 principals in GIS. GIS is about what things might look like and how they might look different. Now you're also going to face some conversations probably with your peers, because as they sit there and plan and are nervous about making sure that they follow a continuum that has been set up that really doesn't always follow the shifts that we need to probably follow in our mathematics process, they're going to be some may be very resistant, hesitant, skeptical. And so you're going to be there, you're going to be basically the pioneers of what's going to happen and seed out to the district as a whole. You are the change agents for Clovis Unified. The work that you're doing is the work that everybody's going to do, going to want to do, as we continue to figure out this thing called our new safe math standards and smarter balanced assessment. So a great suggestion over there was don't go to your peers and tell them how to teach differently. Oh, this is what you need to do. I learned this. This is what you need to do. And but have conversations about how students are learning differently. That was a great point. And share with them the conversations your kids are having or the things that they're accomplishing. And they're going to want to come in and see what's happening. They're going to be a little more open. But I tell you what, I know our teachers in Clovis Unified, and I know what we're like. First of all, we're driven by that dang ICAM or the results, and so we've got to change a little bit of that and bring down the angst, at least for us. But they are also, the most common thing I'm hearing is we know about the what, we just really are struggling with that how. We really need support, and what you're doing is in these shifts, and you're starting to think differently about mathematics, you are going to be able to support really a little more of that change of how we go about doing business of mathematics in our schools. So I think they're going to come to you and crave some different things and crave some ideas. And
especially when you show them student work and your students are doing some incredible reasoning and thinking, and how did you get them to do that? Well, they actually came to me with a lot of it. So.
And we have CDT members on here who are participants in the grant. Some of you may become CDT type members to help out so that our units of instruction support shifts. Our assessments need to change over time. They need to be. Right now we're very much Claim 1 skills and concepts centered, and it needs to reflect what we're going to really expect of our students here. But remember, this is a 3-year process for us. Just this is day 5. I know it feels like it's like day 38. But this is day 5. The first intensive week. We're all exhausted.
We have 33 more rooms to look forward to.
That's right. And great things will happen. And great things that happen take time. There are a lot of sacred cows out there. And we need to have conversations with our administration and our peers. And the book tells us that sacred cows make great hamburger. We need to round those sacred cows up. Someone in the last room asked a great question. What if my principal or GIS walks in and they see things so different? And I'm not really sharp because I'm attempting something new and my kids are we're exploring something as opposed to, I said, those are great conversations to have with your administration before they walk into your room. And let them know what's going on. Let them know so when they walk into their room it makes sense to them. That you're not having to defend your practice afterwards. But you should have the right as a professional involved in this program to be able to stick your neck out a little bit, to attempt new things, to start to shift, and be able to defend your practice. And those who have worked with me, that's a statement I used to always use as a principal. You want to try something new or different, they come to me and say, I'm going to try this. Well, defend your practice. It's like I asked my doctor when he said, we're going to do this, defend that practice. Why? And if you can defend that and support it with research and with experience, then they're going to be likely to see, okay, it makes sense, I can support you and move on. But I'm excited to see what happens. Be that change. Be the individuals that are going to seed good work to Clovis Unified. So, Jeff told me not to end with, are there any questions? So I'm trying to bite my tongue. But if anyone wanted to raise their hand. All right, good. My last comment is, like our Facebook page, please. The Facebook page. Get on there and like it. I get to 100 and we get a little thumbs up and we have to shorten our name. And we were 44 yesterday, we're actually 60 something now. There's 130 of us involved in this between the staff and the participants. Please like us. I've now gone to my Facebook friends and asked them to like my page, so and follow it because
what is it?
I'll send you the link via email. Jeff will send it again. It's CNI Camp Grant. No, Clovis Math Grant. Math. I forgot. Clovis Camp Grant, I think is what it is. Does someone see it on there? Okay, so. We'll send you a link, like us, and watch it, because why? We've had your CNI folks who have been in the back of the room posting pictures and posting thoughts, profound things throughout this week. We'll continue to do that. When they're working with small groups and they see something powerful, they're going to throw it on there so you can see it. We'll always be connected. Clovis Camp Grant. Okay? Oh, live off of that. And there's also a link on that page to the Google Drive if you ever can't remember where to go. On the side in the About section, there's a link that takes you to the Google Drive that will open up for you. So, okay, that being said, we've taken too much instructional time, but drop the walls, lower the angst. and move forward as pioneers, because that's really the work that we're doing here. So thank you very much. Appreciate it. And we'll see you at lunch for our picture with the drone, and it's not going to crash.
He still has not answered. 6, 7, 8.
Hello? There. I'm impressed. I go to a lot of districts and take advantage of, I'm just so impressed that it was just presented to you, that you're given permission and time to take risks. I don't hear that in very many districts, and I go to a lot of districts. So take advantage of that. And it's on tape, so in case he forgets. Because this is, it's absolutely true that this is not the kind of teaching that many of us ever tried before. Certainly, probably most of us never experienced before. So it does take risk, and it takes knowing somebody has your back, and it sounds like you guys have that. So I'm thrilled for you. So so let's continue. We have one more little guy to look at. So take a look at Brian's problem, and just double check with the neighbor that you have the type of problem correct. If we don't know the type of problem, it makes it harder for us to figure out what they're doing. So you remember Brian, he was the little guy in our small group?
You're supposed to say what it is.
So what kind of problem do we have here? Oh, I didn't let you guys try out, I'm sorry. Turn to, right after the Matthew, it has, I want to give you guys a chance to practice. So use Matthew's strategy and solve that next problem and see what happens.
If the context bothers you, do cups or do pounds, right? Just fix the context so you feel you can wrap your mind around what you're doing.
What do you do then? 5 times? Actually, how do you do fractions? 1, 2, 3, 5, 10.
So that would make 2 loaves. 2.5. So 25 loaves. The question is 2 or 2 and 1, no, 2 and 5 tenths. That is the 20 part that we need to load. 1/10 times 10 is 5 kilograms. 1/10 times 10 is another 1/10 times 10. Okay.
That's how my brain thinks, and I just want to do that. Take the label and whether it's yes. That's like when you said eating problem. If I didn't put notes next to it when it doesn't go the first time, then I have to like go back and replace it. But if I put notes and I can say the 10 is the number of loads that it'll make, and the 1 is what's kilograms, then it makes sense. Yeah. But if I wouldn't write it, then I reread it. No. 5 10 right?
I'm trying to pull my brain out of the half of it makes sense. I'm trying to, like, instead of
Use a different unit. Something. But not what would you do? What would Matthew have done because of how she solved that?
these are the two. I know, but I can't do it like that. That's what people record with the
Okay, so we think we have it. Somebody want to share what happened when you tried out Matthew's strategy? So what kind of problem type were you solving with these bananas? What kind of problem was it? Measurement division? Okay. So as a division problem, it's asking us how many... Well, no, hold on. Not the measure. That one's not. So what kind of problem type is this one? Well, let's let her solve it first, and then we'll see.
So trying to think like Matthew. Trying to think like Matthew, I would have started with the 1/10 that it takes to make 1 loaf times 10 loaves, and that equals 1, and I did a double 1 kilogram.
Everybody listening? Yes.
So, and I know he's making 25 loaves, so I think he would have done another 1/10 times 10 loaves, and that would equal another kilogram. And then I just assume he would go, okay, so now I've got 20 loaves, I need 5 more, so I do 1/10 times 5 loaves, and that equals 5/10 of a kilogram. I'm not sure if he would have simplified that. So he would say I have 10, 20, 25 loaves, so I have 1, 2, and 5/10 kilograms. That is how much total bananas he needs to make his 25 loaves of bread.
Okay, everybody agree? All right. So how is it different than the story that we saw Matthew solve? Because in the story we saw him solve, he used something that looked very similar, right? He went like this. And he didn't write this, but we can do that. And where was his, then what did he do to get his answer? How is it different?
Or do it 5 times.
And the answer was 21, right?
31.
Oh, well, oh yeah, it was 31. He did one more, sorry. So how's that different? Say more.
The last one says something, it represents something different, whereas the first 3 represent, what were they? Each one represented pounds, or days. And then the last one represents a tenth of a pound for 1 day. Oh, I can't remember. I don't know why I thought that there. I'm struggling now, but it represents something different than the tens.
You know why you're struggling? Because this is hard. So you're not struggling because there's something wrong with us. We're not struggling because we don't understand math, or we're not good at math. We're struggling because this is hard. And it was 2 questions ago, right? Oh my gosh, I'm just learning, so slow down. So let me give you a little bit of time at your tables. What's the same and what's different about these 2 strategies? So the bottom one's Matthews.
When they did it back here, I would have shot. I would have taken this one. Oh. I was surprised. So, yeah. So, when he did the pet food, he needed to know the number of fruits. When he did the banana bread, he already knew the number of fruits. He needed to know the total product.
He used the same on one side. Division problem, I think it's relevant for both. So if it's not relevant, I know.
Yeah, I would put it right on my desk. Or in my math folder. Something. But I love what you just said. Technically, they did 250, but they used the same them 2, 3, and 4 different rules. Save, and they keep track of their units. They have to remember what is what. You still send the
So let's come back together, because this is a pretty important idea for us to kind of think about together. So as you're looking at those 2 strategies, the top one that was, I'm sorry, Katie's for the banana problem, and the bottom one was Matthew's for the feed problem. What did you notice that was similar or different?
You have to do the 1/10 times 10.
So both of them use 1/10 times 10 equals 1. Both of them are based on this basic basic, powerful concept of how many unit fractions are in a whole. Okay. They're both using the same unit fraction, yeah. 1/10, so it's place value understanding too is being built here. What else do you notice? What's different?
The difference is where they're going to find their answer.
Where they're going to find their answer. So,
in Matthew's that he did himself, he needed to add up the number of groups of 1/10. So he had to keep track of the 10, the 10, the 10, the 10, and the 1. And in the second problem,
which is the top one.
The top one, we needed to keep track of the totals. How many wholes, how many ones.
Right? Everybody agree with that?
Yes.
So the bottom one, Matthew was needed to keep track, needed to find how many groups of 1/10 were in a number. The top one, they were trying to find out this many groups of 1/10 is how much. So what's that mean? Are they the same problem type?
No.
No. What's the top one?
Multiplication.
Multiplication. So it's asking how much is 25 groups of 1/10. So she knew how many groups. She knew I had to stop after I made 25 groups, right?
I wouldn't have done.
So I'm going to make 10 groups, and then another 10 groups, and another 5 groups. And then I'm going to stop and see, how much did I make? Well, with 10 groups, 1 kilogram. With the other 10, another kilogram. With the other 5, half of that, or 5/10. So she knew how many groups, but was trying to find out how much that would be altogether. What's the bottom one? What's the one that Matthew solved? Measurement. So he's trying to find out how many groups of 1/10 are in 31. So he didn't know how many groups to make. Yeah, not 31, sorry.
Matthew's is the bottom one. The top one.
Which one is, this is Matthew's, right? So how many groups of 1/10 are in 31/10ths, or in 3 1/10? So he didn't know the number of groups, but he knew that I need to get to 3 1/10ths. So in the top one, I have to make 25 groups of 1/10. In the bottom one, I have to pull 1/10 out a certain amount of times out of this 3 1/10. But when we look at them, they're both using the same mathematics. They just have to keep track of what these numbers mean. What's helping them keep track of what the numbers mean? The story. The story is just not a nice little thing to stick some numbers into. The story is what is helping you solve it. It is what's telling you what to do.
Okay, so I have a question, and it's just maybe because I'm tired, but for me, I think that would we actually explicitly teach because they have to understand the problem first, the story first, right? Would we need to explicitly teach them pulling out the product information, the amount in a group information, the number of groups information, or is that supposed to evolve?
So they're doing it, right? But it's really going to be important for us to explicitly ask them questions like, what does this mean in the story? It means what does it mean in the story? Is it the number of days? So that's going to be really important. So they're learning that there's these groups, the amount in each group and a total, and they're using it to solve the problem. So they're demonstrating to you that they are using their understanding, but we want to help them make it explicit. The more we come back and ask them things like, what's the 1/10 times 10 mean in the story? That's going to really cement what's going on here. And that's what they're going to have to be thinking about, so the story eventually can go away and we can just look at equations and think in the same way. So I think, anything else that came out in your groups about this? Similarities, differences? Yeah.
Oh, well, I just have a question, sorry.
No, sorry.
So, no, I forgot my question. How important is it in a whole group setting? I mean, you can't get to every kid to ask them questions. So is that demonstration piece where you have 3 or 4 kids come up, is that where you build in your questioning, and maybe if you ask those kids questions, you're hitting everybody almost?
Yeah. So sharing time is going to be critical, because that's when you're going to be able to directly instruct using kids thinking. But don't feel you have to do it every day. You can have the kids just turn and talk in small groups and explain their thinking. You can walk around and talk to a few kids as they're solving problems and push on some of their thinking. Tell me what this means in your story. You can choose a couple of kids to come up for the whole group that you think makes sense for where your group's at, or a big idea that you want to. Maybe nobody's notating, or maybe Matthew is the first one that started notating it. So bring the notation and the picture together. Your embedded days, I'm not with you for the embedded days. Jeannie Barron or Melanie Wenwick will be, but I'm trying to see if I have those days available so I can come up and play with you guys in your classroom, but you're going to get to practice this kind of stuff with your kids. So, but the things you're thinking about now are exactly right. I mean, we have that intuitiveness as teachers. We bring with us this rich experience of what we've done in the classroom. So yeah, now kids sharing and you making decisions is kind of the nice thing to be thinking about. So if I have a lot of kids that are using pictures and one person starts putting up some numbers and number sentences, hey, where's that in that picture? So that the picture kids can begin to, what would you write for your picture? Or the kids that you think don't need the picture, the next day you say, remember we looked at that? Do you think you could do it with numbers instead of pictures today? Or try your picture first and then see what numbers you would put on it. So you get to really build on where kids are more individually or as a small group. And it comes over time. It doesn't feel very purposeful at first, but it comes over time. So I think another really big thing I heard a couple of tables talking about is we tend to teach 2 different rules for multiplying fractions and for dividing fractions, right? When I multiply a fraction, I make sure it's in improper fraction if I need to, right? So I don't want anybody to miss this. And I'm not saying your conversation's unimportant, but just this one I'm going to pull us back. So if you think about multiplying fractions, let's just say it's a mixed number. We would have to change the mixed number to an improper fraction. We would have to, or if it's a whole number, put a 1 under it, right? Multiply the top, multiply the bottom, simplify. Versus division, so we'd have to change it if we need to an improper fraction, invert and multiply. Multiply top, multiply bottom. And think about the understanding that kids would come away with from that kind of experiences versus these kind of experiences. And in this one, I can use the same kind of thinking to solve a division problem, a measurement division, not so easily partitive. Because it's more, well, but if the structure is different, it's not going to let us, because we don't know the amount in each group. So how am I going to make groups of a number that I don't know? How am I going to pull out a number I don't know, right? So that's why partitive is not going to do that. It's going to help us understand a fraction. But if I need to pull out 3/4, I need to have 3/4. I don't have it in a partitive division. That's what I'm trying to find. So that's why that one's not going to do the same thing these guys are going to do. So, so the kids can use the same thinking to solve 2 different problems types because of the relationship that they're discovering between multiplication and division. It's what they do naturally. Any other thoughts or questions about that? Another thing they're doing, math, 6th grade, I think it's in 5th grade too, but 6th grade, kids have to write stories to equations. So they would be given an equation like 4 3/5 divided by 1/5. Write a story problem that would match this equation. How do I write a story problem for you? Multiply 5 times 4 and then plus 3 and then put it over 5 and then invert. It's not a story problem. So they're also getting to feel what these operations, what this whole equation at the end. They're starting at the beginning with this story and this meaning. So hopefully, when they get to seeing, hey, what you just did looks like this: 4 3/5 divided by 1/5. They can begin to go, oh, so what would a story sound like? Oh, you have this, and if you're going to do this many each day, how many days will it take you? So they have a better chance to it relating it the other way. All right, so let's take a look at Brian. And we know what kind of problem type he's solving. Make sure you... Is it multiplication or measurement division? Measurement division? So it says, can I read it? Thank you. Takes 1/5 of a gallon of paint to paint 1 doghouse. How many doghouses can you paint with 4 3/5 gallons of paint? So act it out. What do I have? I have 4 3/5 gallons of paint, right? What am I going to do with that? I'm going to use 1/5 of it, and that's going to do 1 doghouse. Then what am I going to do? Keep doing it. Paint another one. What kind of problem does that look like? Not partitive. Partitive, I know how many doghouses. Measurement. Yeah, I have my total. I'm going to put 1/5 here, and that's 1 doghouse. I'm going to keep doing it. It's that repeated subtraction. Okay? So I'm going to figure out how many doghouses I can paint till I'm all run out of paint.
Have you ever built anything?
Built?
Like nails and boards and hammers?
I helped my dad build a restaurant in Mexico.
Whoa, that's pretty cool. That's a big thing. This story is about a little kind of a building, doghouse. And so people build doghouses, right? And I've seen them, they sell them along the road, and you can stop and buy one. So this one's about building doghouses and then painting them with paint. So do you want to read that story to us, and then see what you do with that one?
It takes 1/5 of a gallon of paint to paint 1 doghouse. How many doghouses can you paint with 4 3/5 gallon of paint?
Does that story make sense to you? Yeah? You want to see about how you might solve it? Do you think you have an answer?
Yeah.
What's your answer?
23.
23 what?
Huh?
23 what?
23 23 doghouses.
You want to write that down? Just so I remember what that 23 represents, means. Okay, tell us what you did to solve that.
If you do 4 holes, and that would be 5 times 4, so that would get you 20. And then you just add the 3/5, and that's 23.
Okay. So tell me more about what you mean 5 times 4 equals 20. How did you know to do that?
Well, I knew that 5/5 was 1 whole, so I did that 4 times, and I got 20/5, which is 4 wholes, and that's how I got it.
So 5/5
Equals 1.
1 whole? And in a story, what does that mean?
5/5, that would be 1 whole gallon.
1 whole gallon? And how many dog houses?
That would be 5 dog houses.
Okay. And then how'd you get the 20 again? So I understand 5/5 is 1.
And then I did 5/5 equals 1. So if you do that 4 times, it would be 5, 10, 15, 20.
5, 10, 15, 20. Okay. All right. Thank you.
All right, so spend some time. What in the world's going on there?
Those 5 minutes.
So, I want to know why is it important that she makes it because this was but when he talks about it, he spoke about it correctly, so it didn't matter, and he wrote it in. Yeah, and he ended up with the right math in his head, but it did not matter.
So we have some case notes for you. That would bring her card. Did he write one? That all this is but he didn't need like his
So before we take a look at Brian's, I want to look back at the little guy just before Brian with the 1/10. How would Matthew have solved this one? Yeah, I'm just going to flip it so it's the groups of 5 groups of 1/5 equals 1. What would I have done next? 5 groups of 1/5 equals 1. When am I going to stop this craziness?
When I get to 4 wholes.
When I get to my total of 4 wholes. So stay with me with this one, especially 6th grade teachers and 5th. Not that I'm leaving 4th out, but this is going to be a really important one. Then 5 groups of 1/5 equals 1. What do I do next? 5 groups of 1/5 equals 1. 3 groups of 1/5 equals 3/5. So I was trying to get to 4 and 3/5, right? So I got to my 4 and 3/5. Where's my answer?
5.
How many of those 1/5 it took me to get there, right? And how many did it take me to get there? 23. Okay? So I've got to get to 4 and 3/5, but I want to get there keeping track of how many 1/5 there are along the way, because that's what you're asking me. Saying how many 1/5 are you going to take to get there. So Brian, what was his thinking? He did the first step in his head. So that's in his head. And then what did he do there? Multiplied it by 4. Why 4? He's not additive. He's not adding the same group. What's he doing? He just doesn't know how to write it. I'm writing it the best way I can because the associative property is tough to write. So how would we write it? I have this amount 4 times. So the associative property, because there's no addition now, it's gone away. He's using groups of groups. And he can do that because these groups are the same size. What can we do in multiplication? If we have the same size groups, we can multiply instead of add. But he's now seeing an expression as a group size, not a number. I mean, it represents a number. But he's seeing this as the same as a number, which it is. So that expression represents 1. So where's his 20 in here? Well, the associative property says I can multiply these 2 together or these 2 together. When I multiply these 2 together, I get 20/5. That's what I need to know, how many fifths. When I multiply these 2 together, what do I get? 4. Freaks me out. Associative property still freaks me out. Because we're just like doing this and we get 2 different ideas. How's that happen? Because I can call this 1, 4 groups of 1, or 20 groups of 1/5. I think my kids were thinking like this in 3rd grade. I just didn't recognize it. So I would have written this with Brian. Oh, so Brian, what you said was 5 groups of 1/5 plus 5 groups of 1. I would have made him stay distributive when he had much more powerful thinking. I didn't recognize it. I know I didn't. I'm sure a few of my kids were using that, or often, many of my kids. So when I have same-sign groups, I can multiply. It doesn't matter what these guys look like. They all represent the same amount. Kind of amazing, huh? Now he has to use the distributive here, because really the whole thing would be 4 groups of 5 groups of 1/5. Right? We have 4 groups of 5 groups of 1/5. But what else do we have?
3
Plus. We can't say we have 5 groups of anything, right? We do have 5 groups, but only 4 of them are the same. So that's why I can multiply. I can't multiply this guy. I can't say I have 5 of anything, because I have to multiply same units. So there's that same units. But I'm going to tack this guy on and say there's 3 more 1/5 in case you need to know. So where are my 1/5? Well, here's 20 of them, and here's 3 more of them.
Don't you have to put the 3 times 1/5 in parentheses?
You don't have to, because of order of operations, but I like to because it helps you focus on what's happening in the story. Yeah, I think it's really it supports me, and I think it supports the kids. So I think they're powerful to keep our eyes on these chunks of things. So let's stick Brian's up here.
Jones,
yeah.
I have a question.
Why wasn't it important for us to make him fix the part of his math that was wrong? His thinking was correct, but what he wrote was incorrect. Why wasn't it important?
I'll tell you why I didn't quite know what was going on.
Okay.
So after I knew something wasn't right, but on the spot, I couldn't quickly enough decide what to do. I know Brian pretty well, so I'm hoping to go back and see what he does next year. But afterwards, the gal Tatum was the author of your book, and I'm like, I think I missed something. She goes, that's okay. I said, no, I missed a big thing there, didn't I? I said, that's okay, that's okay. I'm like, yeah, we didn't get nothing. So Brian would have been perfect to mess with because he had such nice understanding. It was in his head. He needs a way to to get his thinking down on paper, because if you don't, you're going to lose track sometimes, you can't explain it to other people. So Brian's a good example of someone who we would want to spend some time. Let's talk about how you would write what, and you heard him explain it perfectly. So his explanation is perfect, it's just not written correctly mathematically. So he's a perfect candidate to, and you may have to do like me, you know, I'm going to come back tomorrow because I need to think about how in the world I'm going to write this too. So, Brian, come here. You know, you wrote this yesterday, we knew something wasn't quite right, what you were thinking was perfect, but we knew it didn't quite make sense, so let's talk about it, because I thought about it, you know, last night, I think I can help you. So sometimes it will be later, especially in 5th, 6th grade, not the 4th. 4th's going to start doing stuff too, but, you know, how am I going to notate what's going to so you're not going to do it, you're not going to do the same kind of notation with somebody who's doing a picture. You might just want them to get down, you know, 1/10 plus 1/10 plus 1/10. But yeah, we don't want to leave it incorrect. But sometimes you make a decision, I'm not going to do it today because this is the first time he's tried this. So, but I'm going to put that in the back of my head that we got to clean that up.
Yeah. Like if it was his first time and it was incorrect, because his thinking was okay, leaving it and watching it for the next time might be just fine.
Yeah, you can make that decision. You could tell him just so he knows. And you could say, I mean, you could give him the challenge. I see what your thinking is. It doesn't quite, how I see what you wrote means this.
Okay.
But what you're saying makes sense to me. Do you think you could figure out a way to write down what you're saying where I could see where? So you could give them the challenge. You could say you want some help with that. You could ignore it for that day. You could say, this doesn't quite match your thinking, but we're going to talk about that together in a small group. I mean, whatever makes sense for you. Because you may have a few others that could benefit from that, who are almost there. So it's like, let's get together. What do you guys think? Is this what? Brian said this. Does this match it? No. So how can we match it? So it's fun. It gives you, you know, you just get to do what makes sense. And
So Joan, when would you try to introduce the parentheses 4 times what's inside?
I do pretty early, even with little guys, just to focus on an idea in the story.
It seems to me like he understands the repetitive addition already. He understands that. So when would you say, well, look at here, this is what we could do to multiply 4 by all of that?
Yeah.
Because that's what he's doing in his head, but he doesn't know how to write it on paper yet.
That's a really nice thing to think about, because Matthew is going to do it like this, right?
Yeah.
So there may be a help for Brian. Brian, what did you do? Well, I did that once and just multiplied it by 4. Okay, so let's do that. You did this once and then you multiplied this by 4. So you could use another kit to say, Brian just went from this to something a little more sophisticated mathematically. I don't know if that's true, because they're both using both using properties. But the associative property later in fractions is going to be like, whoa, blow you out of your socks. When you use the associative property with fractions, when kids start doing it, it's pretty fascinating.
When do you start having them put a name? Like, so when we say like associative and distributive, and so, you know, going back to like not teaching them numerator, denominator, like at what point do we have them start making the associations that, do you know what method you're using? Because I don't want to mess them up.
I would. Man, if you had a David and a Matthew, or Brian and a Matthew, or put 2 girls, because girls do this too. Just to let you know. And they do it neater, and they care more about it. And they're cuter. But man, if you have a Matthew, and they're in the same grade, so Matthew and Brian together, perfect time to say, hey, you know what? You guys use 2 big properties of multiplication. Let's see how they're similar and different. Stick them up there. So that's perfect. This one's the distributive property. How's it different? This one's the associative property. Or how are they similar? How are they different? So I thought the distributive property was the king of all properties. I don't know where I learned that. And now I think it's the associative. Well, actually, I think both, but I'm so enthralled with the associative property.
But you maybe don't write it down. You just
Why not?
Because I don't, well, that's what I'm saying. Like, the other day we were talking about not taking their pure knowledge and confusing it by throwing in all this stuff. So at what time do we then start saying, you know, this is the distributed property, and you know, so it's like, or do you just kind of, oh, this is the distributed property, and then touch on, and then like the 10th time you've brought up the distributed property, you then write it down on the board and go.
When timing makes sense. I'm not going to do it with Sarah or Maddie.
Yeah.
Right? But let's talk about your picture.
The way that I think about something like that, how often when your kids are learning to talk, do you go around and make them memorize and tell you that is oven, that is refrigerator, these are shoes, this is pants, this is, you just use the language.
Right.
And they naturally pick up that that's what it is.
So you don't ever really have to officially start, you know, get out your math journals.
Yes, what is a distributed property? You need to recognize it 10 times on this paper. I think as they're learning these properties, you're using the language.
Yeah, it just becomes a part
and
of
it becomes part of the language. And then you may start asking, does anybody know what property they actually use there? And if no one knows, then, well, that was a distributed property. Oh, you're right, that was. How did you know that? And then it becomes part of the culture of the conversation, not memorize all these vocabulary words.
Right, exactly.
You could have a little place in later on in the year, and kids could go and put their strategy where if they think it's in the associative or the distributive. So just an example. Here's some examples of when we use the associative property this year. Here's one examples we use the distributive property this year. The commutative property. Commutative property comes way late. We think the commutative property comes first. It only comes first because we tell the kids you can flip it. It doesn't come first because they understand. It's the later one. Kids use the distributive property and multiplication way earlier than with big numbers and with fractions.
I guess starting
way
with
earlier.
addition, subtraction, getting them to be able to subtract, because if we know 7 plus 8 is, you know, like fact family, so the commutative kind of comes in then.
Yeah, but think about it. What 7 plus 8, 7 and 8 are the same units. 7 apples and 8 units, 8 apples. I can't say if I have 7 apples and 8 oranges, I have 15 of anything unless I change the...
Right, but just because of the normal progression, like starting in 1st grade up till when I get them, they're exposed to a lot of commutative terms, right?
Yeah, addition comes along really quickly. Little kids in kindergarten start using the...
So they're familiar.
But it's because of what it means. I have 5 marbles in this hand and 7 marbles in this hand, and addition means just put them together. But how would I intuitively know that 37 bags with 27 cookies in each bag is the same as 27 bags with 37 cookies in each bag? I have no idea. One feels bigger. Because the 37 and the 27 mean different things. One's groups, one's number in a group. How do I just flip those? It's kind of interesting to try and prove. So it comes early only if we teach them. Understanding comes much later. Arrays help, but it's pretty hard to comprehend why 37 groups of 18 cookies. 37 bags with 18 cookies would give you the same number of cookies as 18 bags with 37 cookies? Doesn't one feel bigger than the other one to you? I don't know which one feels bigger to me, but one does. I think the 18 bags with 37, I don't know why. So to prove it's a little tougher. If you had to prove it without an array, if you had to prove it with equations.
You want to be part of the group that was doing the 36. You want to be part of the group of 18. You'll be getting 37 cookies.
Yeah.
So you can think about it like that. What situation if you were one of the kids? But the total number is, messy. Yeah. That's a good thing for you, for people that want interesting thing, is to prove it with equations that 37 times 25 is the same as 25 times 37 or something. It's fun. Believe it or not, it's kind of fun. All right, so let's get I'm going to put all the kids' strategies up there, and then what I want you to do is, how would you arrange them? They all solved a multiplication or measurement division problem with a unit fraction in the amount per group. How would you arrange them from least to most sophisticated? Not from good to bad, but from least to most sophisticated. Let me put Brian's up there.
Hey guys, while she's doing that, just something really quick. When we take, between now and about 12:40 or 12:30, when we go out in the halls, if we can try to keep it, there's a memorial service going on in the ballroom right now. So just so that we are aware, just all of us out there at the same time, it just naturally gets loud without even realizing it. So just so that we're respectful of that.
Yeah. They all different, yeah.
Make as much noise in here as you want.
First aid, so you can put them, put them on a continuum of understanding. How would you put it on a continuum?
Well, then I'm saying that
I know. What did she tell them?
Weeds to heart.
Yeah. I mean, it was so dramatic for her use of this. Easiest thing to first.
Based on the pictures.
I've also been
What'd you guys come up with?
That's highest to lowest. You want lowest to highest?
Lowest to highest. We went Rosie, more divine is Rosie. Okay, but look at Rosie. The only reason why we switched divine and Rosie around. That's the only Rosie used trial and error to start. Rosie made mistakes. That's why we divined it. She had to do the trial and error. She's not using a picture, but she still has to represent all these. Don't switch them. I'm just telling you why. That's why we. That's why we yeah, I really like that. It's like the tree paper was almost did you hear from him? And where is it? So hot up there.
Yeah, no, I was thinking of the girl they showed yesterday that her pickup was 1/4, and then she was like 10.
It's hard to see. It's hard to know. Like, what should she have done?
Brian.
Oh, that was like someone would have to show. Someone would have to show.
I'm thinking that maybe Sarah is easier because she put fractions instead of zeros. And added
So she's higher than
I wrote easier. She made it easier. She put numbers in.
Those are my
So after you're done ranking them, go ahead and take your break until 10 till 9:50, and then I'll rearrange them into the ranking, and you can come back and see what you thought.
Because they're so far removed. Just like when I started my health obviously
It's for solar panels. I'm thinking of like plug-in. Oh no. This is an inline string inverter. So actually for electricity back. Done it 3 times. I've known that box. Instead of having 250, I have 500. You don't have 500.
Yes. You just bought from the same company?
Yeah, no, well, what happened is what they used to do, they would sell you refurbished. There's resistors and transistors that wear out with time.
Right.
And they decided it's not worth it. No longer serve them. What we'll do is we'll give you a deal on the new unit, 10-year warranty.
5 kilowatts for the 2.
Right. So I call it a solar company. That's the base price. Because I think I paid price online but the units, smaller units were that much by themselves. Big last week for 9 years. Those did, but it's hard to tell you. One guy actually working like this. I said, because he told me 500.
I hate that when they start getting
I have that because I have
so when you go back and exactly
burn it up. Put it in swap work, it's hot. Because I have two identical units supposed to be identical. One black shows here and one black
starting at 50.
They feel fine now, but it hurt too much.
Yeah, it died.
It hurt too much.
I'm not housing. 2 more. I'm not housing. However many she'll give me.
Okay, so do you think you can get away without TVs and magic balls?
So with 6 weeks,
that's kind of funny.
And then maybe next week. You know, like how did you figure that out? And then build the rest of
you know, they say these things, they don't think that they're going to last maybe a little over the 5 years. That you're lucky to continue. The guy said, this is the most expensive. The only thing that comes up, but he didn't tell me that. It was 5 years and 3 months. You know what? I don't know. When I put on the go, read out the numbers and do all the stuff that I have. It even has interfaces to internet SD card in it and download it on the computer. With a research.
You know how well the panel is. Yeah. I mean, is there any way to tell it where you're at?
My brother-in-law. He told me with the panels he worked with medicine because he would do like remote areas up in the mountains that ran on solar panels. And he said that if part of your panels are shade, like the whole panel, he said it's really weird, but
What are they doing? Like a hard book?
I studied it. It was like, crap, that one was pretty easy. You just take a picture, label all the wires, the same wires that do it at night. Well, this one, I'm taking those components and folding them down. Some people, it was not that much, but I didn't want to have I did a full-size sheet, put it on the wall where my conduit went.
Are they got studios like this summer?
Yeah, we're going to put it in the original conduit. The permanent board connection. Several hours talking to us about it.
The first track too, and then it was like, and then it was like, I don't know, you fourth grade, right?
They had the pre-test.
Elements
No, I read the customer reviews. Do you play new
Did you study? You read? To share what it was like to play, to train
I was hoping to find someone like myself that had these units. I know they're dying every between 5 and 10.
You take the
That's the other reason I don't want to do weighs less than the one I'm going to put in. And the way it's flipped on. This body is small.
Same company yet?
Same company.
10-year
warranty
warranty.
and you should buy it a month. I could buy $5 I can buy another 5. And I'm reading verbal arguments like engineers and stuff. I can't get
yeah, and some of us are not there. You know what I mean?
I don't know.
No, I feel
like the reverse ones are going to say, except back to the worst now. But I think the first time I did that, I'm told our dog for another unit. But it lasted. But 6 years. 6 years again. But yeah, and they've actually, what they've done is, Arista, one of the parts of where they've made it. Everything I plug is all in ways to save other ways to save. These are like some don't work from home. 31 is off this new
Letting the kids know that's let's put that on our wall so they can come. Yeah, we spent so much time on construction this year.
Well, now you get a week outlet.
And I love teaching out social studies and science. I have years. This is what we do at our site during which social studies.
That's useless. Like, I want to pay $500.
I mean, I would just give them, hey, this is the deadline. You have to get done. 2 weeks before school, you have to get done.
I don't care. That's too hard.
Because
crazy.
social studies is free. They're that informational text that we're speaking to. So that becomes part of our language. I'm on an Andrew. It is not something I do all, but it joins the next one. It is rotate. And so then now we do all the tests. And social studies open book tests, and I tell them everything. The whole point of us teaching your child social studies is not so much. It's high interest for most of them, especially science. They love it. But it's teaching them how to navigate a non-fiction and use headings to guide you toward information. I do not expect your child to memorize the day California is, but I expect them once we've learned it in class, and once we've read it together in class, and outlined the chapter in class, and they've had like over 100 pages of social studies and science are worthwhile. I expect them to remember. We talked about that. That's in lesson 3. Let me go back again. But I am finding, and I like I always take the chapter and it's not really just to like read. I do expect them to understand the process. Like I really would like getting to understand that's right. And most of them, yes, but I actually have some teachers that even the some of the main points to your you know, I think they need to understand it's a great time to and understand
All right, so you can go ahead and head back to your table and take a look at back at the window. So when kids solve these multiplication and or measurement division, they solve them in 3 particular ways. And so we have 3 groups over there. So Maddie and Divine are solving them using a similar kind of thinking. Looks very different, but the mathematics that's involved is very similar, and we'll talk about why. Sarah kind of is standing on her own right now, showing us what that a little more sophisticated strategy looks like. And then Rosie, Matthew, and Brian are in that 3rd kind of category. So what puts them there, right? Well, what puts them there is the mathematics that, the level of, the depth of the mathematics that they understand. They all are engaged in the same problem or very similar problem. So they're all doing the same mathematics. They're just doing it with different levels of understanding. So it's not about this kid can do it and this kid can't. They all did it. But they all have different levels of understanding, and all of them have something to learn, even Brian. So it's finding where kids are at, knowing where they're headed, and then making decisions based on some professional decisions we begin to make with that knowledge. So This earliest level of strategies is not based on the age of the kid. I've gone in a second grade classroom and seen kids doing these strategies, more here, but a couple of them here. And I've gone into 7th and 8th grade and seen kids here. It's about the opportunities they've had. So the more opportunities they have, regardless of the grade level, if they have a lot of opportunities, we see kids more at this end. At the end of those opportunities, more kids are doing these kinds of strategies. So the mathematics that separates it is two things. How they're thinking, how they're representing the whole, if they have to represent the whole, and if every group is physically represented somehow. So how they're representing the whole, and is every group represented. So when we look at these two, we see the 1/3 and what else? The 3/3. I can't yet think of the 1/3 on its own. I have to think about it in its whole, which is a fine place to be, but that's an early thinking. So I see the 1/3 and the 3/3. Do I see that same thing here? I see the 1/5 and I see the 5/5 that come along with it. But I only am seeing it with one. These are going away, right? So you may see somebody that has to do all of them in this group, but divine you can see is kind of moving out of that. So it's not, this is a continuum too. You're going to see kids gradually not have to represent every single one. But they're both in what's called direct modeling. One's a picture, one's a number, but the key determination is I have the 1/5 and the 5/5. I have to have that still. And we see every single group represented. And this is starting to go away. But I can touch all 12 1/3, right? I can touch almost earlier. She's moving out of that. She started not to need these others, but we could, if they do kind of fan those out, we would be able to touch all of the 23. So that's direct modeling. So this is different. How are they representing the whole? Yeah, they're able to abstract the 1/2 and show it on its own. They don't need to have the whole along with the 1/2. So I can pull a 1/2 out and I don't need its other 1/2 sitting there, either in a picture or in a number. And so that I get to start adding. Over here I'm just kind of counting, right? 1, 2, 3, 4, 5, 6, 7. Now I'm beginning to add. And in unit fractions I'm making, 2 1/2 is a whole. So these are counting and adding strategies. And the whole's not represented with the part. So they're going to be using more numbers here. But we can still see all 8 1/2s, right? I can touch them. 1, 2, 3, 4, 5, 6, 7, 8. I can see all of them. I can see all 23/5. This is starting to go away, so that kind of would overlap. I can see all 12 1/3s. What happens here, not only has the whole gone away, but you can't touch all the groups. They're all accounted for. They're hidden in bigger groups. So where are 23 1/5? Well, I can't touch them. They're all there, but they're hidden within a group of groups. So now we don't see every single group represented. It's all accounted for, right? They're in there, but I can't touch every single one. So here's 5 of them. Rosie still had to kind of show I could touch all 5 in Rosie's. 5 of them's in here, 10 of them's in here, 5 of them's in here, 3 of them's in here. Same with Matthew. Where's his 31? 10 of them in there, 10 in there, 10 in there, 10 in there. There's no 10 1/10s anywhere individually that I can touch. These two are similar because they're finding a nice group, and in this case 1, because we use the unit fraction, and they're repeating it additively. This one plus this one plus this one. This group plus this group, plus this group. Brian found one group, and what did he do? He didn't add it, he multiplied it. So we have, in this is called relational thinking, and I have a sheet for you. This is grouping and combining. I find the groups and I combine them, and it's additive. This one's multiplicative thinking. This is the thinking needed for ratios, proportions. And it's developed through here, but he's using that multiplicative thinking. Not additively, it's 4 plus 1 plus 1 plus 1, but 4 times as large. So direct modeling, counting and adding strategies, and relational thinking. Grouping and combining, and then multiplicative. So they all look very different. If you give any one problem to your kids, you're going to have these strategies that look really different. But now you can think, I really only have 3 differences in the mathematical levels of that my kids are showing. And you may not have too many over here early on. So don't be disappointed. It comes after time. But don't be disappointed if not too many are there.
Joel, what was Sarah?
Oh, Sarah is counting adding. Let me get that handout going around, then you'll have it. I'm sorry it kind of came out light, but you have the levels and then kind of a sample. Can I get you? So that'll come around the chart that shows the levels of strategies. This is only for multiplication and measurement division. Partitive division, this doesn't work because we don't have the fraction, right? So we're not making groups or pulling out groups of the fraction, we're creating fractions. So don't think about this chart with partitive. Think about your non-emergent, non-emergent, what's the middle one? I just lost it. Non-anticipatory, emergent anticipatory, and anticipatory for partitive, and this is for measurement division and multiplication. So I want to give you a chance to practice identifying these strategies in kids, or these levels in kids' strategies.
Joan?
Yeah.
Can I ask, did you say that direct modeling is non-anticipatory?
No, separate those two.
Okay.
So, no. Why you guys are sorry for asking questions? Yeah, how dare you ask questions? You know that this is a room that is, no question should ever be asked. I don't want you to mix partitive with these guys. Partitive, we're looking at how they understand a fraction, so that is non-anticipatory, emergent anticipatory, anticipatory. But now that they're understanding a fraction, we're going to give them some of these, and now we're going to see, do you have to direct model using that fraction to multiply or divide it, counting, adding, or more relational. So the partitive is special because we're looking at how they're understanding the numerator and denominator. So we pull it out, and then these are, and all of these 3 strategies go with anything. Your Patriot, what your other counterparts over there, they're learning these 3 levels with little numbers. When kids multiply and divide 3 times 5, guess what they do? 3 groups of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Every single one is shown. Direct modeling. Then they start skip counting. Then they start doing some other kind of groupings. All right, so you should have a sheet that has starts with Hannah. So Hannah, as you can see, she's going to be direct modeling is already there for you, but see if you can find the details that would in strategy that make her a direct modeler with this problem. And just because Brian was relational thinking in this one, if we give him a problem where the numbers are a little more difficult, he might go back, and they often do. That's why these unit fractions are so important, because they can do these higher levels with the unit fractions and use it later on. But he could go back to counting and adding. I mean, he might even go back to direct modeling, but he very likely could go back to either counting and adding or more like a Rosie and a Matthew kind of thing. He could do the same thing, but it's not saying once you're a relational thinker always. The problem gets harder. We go back and have to draw pictures all of a sudden. Okay, so here's Hannah. Check with the neighbor, make sure you agree what kind of problem Hannah's solving. So without knowing what kind of problem, it's hard to follow their strategy. Is she making groups of this fraction, or is she pulling this fraction out of a... multiplication or measurement division? Am I building groups of that fraction or pulling groups of that fraction out? Yeah, measuring out or pulling out groups of this size fraction. What's different about the fraction now?
It's not a unit fraction.
Not a unit fraction. And I strongly encourage you to give lots of unit fractions. It's amazing what understanding is built from here that will transfer. I know we want to get into the other fractions. I'm 6th grade, I've got to do 2/3 and 5/7, and yeah, you do. But this is where it's built here. So don't go too far away, or don't miss the opportunity to let your kids develop this this deep understanding with the unit fraction.
Hannah, you are going to make cookies today, okay? So you have 3/5. So it takes 3/5. I'll just read the problem to you. How about that? So Hannah's making cookies. It takes 3/5 a cup of brown sugar to make each batch. If Hannah has 12 cups of brown sugar, how many batches of cookies can she make?
Can I look it out on the paper?
Absolutely.
Can I have a problem in front of me so I can mark it?
It's right here.
Okay.
Here's your number set. So Hannah's making cookies. It takes 3/5 a cup of brown sugar to make each batch. If you have 12 cups of brown sugar, how many batches of cookies can you make?
Okay.
Bless you.
See 3/5, she needs all 5/5 there still.
What are you doing?
I am And
why did you divide them into 5?
because I know she needs 3/5 cups of brown sugar to make each batch. So this is one batch, this is one batch, this is one batch, that's one batch. And I'm counting up each batch, so I know how many batches she needs.
You could be thinking about why the teacher asked that question. Because is there a way she could have already figured out?
A picture where you could stop drawing the picture and think about how to use the picture.
Yes.
Like the patterns, she doesn't have to keep doing it.
Well, I can every time I have 3, I know that that's one batch. Because if you have 3/5, then and if you draw out all the 5 and you put the numbers 1, 2, 3, 1, 2, 3, you know that when you end on 3, it'll be 3/5. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I usually want to count that twice just so I know that it's perfect. So I just want to count it again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Okay.
So can we see why it's a direct modeling strategy? Yeah. So she still needs to see 3/5 as being a part of 5/5. But there is kind of an interesting thing to think about. She has to see, when she draws each of the 12 cups and divides them into fifths, 1, 2, 3, what's that mean in the story? Yeah, it's the 3/5 of brown sugar, but it's also one batch. How does she know it's one batch? At the end, what does she count? She starts to circle them, and then the teacher's like, well, you have some right there in your paper. So she asked that question, is there a place you could stop and use kind of what you have? And so what does she end up doing? Counting the third one, yeah, as the chunk goes. So she does have to see this 3/5 and 5/5, but what about these next 3/5? What is she able to do? They're not in the same hole. So this is something that's not that I took for granted, that she can see them not only when they're in the same hole, but she can still know that I have 3/5 even out of 2 different holes. And that's a big idea that I didn't think was a big idea until I started watching kids. And we'll see that a little bit later, hopefully.
The teacher read the problem here, and the previous one's student counts. Hopefully the student's able to, but it seems like it's more powerful if the student reads stuff.
Yeah, you can do either. Sometimes upper grade teachers will not even show the kids the story because kids want to grab the numbers and look for keywords and do something with them. So sometimes 6th grade teachers purposefully, they'll leave the numbers out. So you're going to have some sugar and you're going to make some cookies, and each recipe needs, and so they get the kids thinking about the story, because the kids think la 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 3/5, la 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 4.5. Well, now we're learning all that la 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 is what's going to tell me what to do. And so what do kids do? La 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 3/4, la 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 4.5. Do I add? Do I subtract? Do I divide? Right? Well, because they don't know the la 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 is what's going to tell them. Isn't that? It's just so kids will tell us, you're being foolish, Mrs. K, don't do that. So when we listen to kids, they help correct our instruction. And so that's a lot of times 6th grade teachers will do it for that reason, or 5th or 4th, especially if kids, I was taught that way. Just, it's the last problem. We did all this addition and the story problems at the end. And if they ever, forbid, change the story problem from what we had done, then I got it wrong. So that's a lot of reasons why you might or might not, yeah. Second grade teachers often read the story to the kids because the old test was a lot of oral. The story problems are oral. So it's good. Oral listening is kind of nice. And that's another way, I mean, if you read the problem to the kids and you say turn to a partner and make sure you both think we're solving the same problem, you're going to see, well, can you read it again? Sure, I can read it again. You know, so they're realizing, I have to comprehend the story. So do whatever you need to do. Once the kids realize the story is going to support them, it's less important. But at the beginning, it might be more important. So we see this idea of direct modeling. So but her understanding, she knows what 3/5 is. She knows that that 5/5 is a whole, that 3/5 is a part of a whole, that 3/5 is comprised of 1/5 and 1/5 and 1/5. That I can combine 2/5 from one whole with 1/5 from the same size whole. Right? It has to be the same size whole. And to create 3/5, so they don't have to be in the same whole, but they have to be from same size wholes, and these are. And that she's counting, she's keeping track that sometimes 5/5 is 1, and sometimes 3/5 is 1, right? Because 5/5 is 1 cup, but 3/5 is one batch. So there's a lot of getting that feeling that in fractions R1 changes. It can, whatever R1 is, once the 1 is set, then everything else has to line up. But I can change my 1, I can change my unit, and then everything else has to line up to fit that. If my unit is 5/5, then one of those is 1/5. If my unit is okay, I was afraid I was going to mess something up, so it's good. Stop before you mess up. Okay. So take a look at the next story that we get to see our friend Divine again. And I believe she's a grade older in this one. No, she's a grade younger in this one. Yeah, she has some pretty incredibly fine glasses. She had a cold this day, but she didn't want to miss out on talking about math. Okay? So Divine is, I made 9 cakes for our spring break, and on every cake I used 2/3 cup of frosting. So how much frosting did I use to frost all the 9 cakes? So is that measurement division or partitive? I mean, measurement division or multiplication? Yeah. So I'm trying to figure out how much is 9 groups of 2/3. So I'm not pulling out the groups of 2/3. I'm building them and then going to figure out how much it is altogether.
Okay, Divine, I have a story about frosting and cakes. So we just had spring break, right? And so my family gets together, and there's quite a few of us. So if I told you that I made 9 little cakes for our spring gathering, and that every cake I made, I used 2/3 cup frosting, how much frosting did I use to make all those cakes, all 9 cakes? So 9 cakes. 9 cakes, and on each cake I used 2/3 cup frosting. How much frosting did I use?
Story for the strategy.
Okay, so as I was doing this, I did, wait.
Can I ask you, do you have an answer?
Like,
Six what? Six what? 6 cups of frosting?
Yeah.
Okay. So go ahead and tell us what you did there.
Okay. So I did 2/3. While I was doing 2/3, I did the 1/3 also. And when I was doing that, I counted 2/3. So 2/3 equals 1 cake. So 1, and 2, 3, 4, 5, 6, 7, 8, and 9. So I had 9, and then I stopped there because that's all the cakes I had. I counted up, and I got 6.
And where'd the 6 come from? How'd you get 6? Where in your paper is the 6?
The cups of frosting. The 2/3 and the 1/3 is 1 cup of frosting.
So where's the 6 cups then?
So it's 1 cup, 2/3 and 1/3, 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 2/3. All those 2/3 and 1/3 together equal 6.
6 what?
6 cups of frosting.
6 cups of frosting. Could you write what that 6 means next to it so we can remember?
And she does, she writes cups of frosting. So talk at your table about divine strategy. Make sure you understand what she was doing there. Make sure you remember what the problem is, because without the problem, we can't understand the strategy.
She made that. She's acted up that. Yeah. It's amazing when she divided versus. So she did what? Each one of
Can only fit into one strategy level. So think about the 2 criteria.
That was wonderful. That was wonderful.
Still represents all the holes in nature.
I couldn't understand what she did. See, I almost feel like it's skip counting addict she's representing.
They represent parts and notes.
No, that was a cut.
The 9 represents
What?
No, because it's asking how many cups. But if it can only be one, she's doing it more. That's true. And that's my point. Because honestly, this shows me a very good life and what it represents. And so,
She's taking every 2/1/3. What's impressive is these actually
because I don't think it is.
4, I'm pretty sure.
4, 5, 6, 7, 8.
I was impressed. She got to the end and she was doing this line.
So we're supposed to identify
So, any questions? You think you understand the mind strategy? You think you worked that out in your groups okay? So what, how would you describe this strategy? If we look at our 2 criteria for direct modeling, she's working with groups of 2/3. Does she have to show the 2/3 along with the extra 1/3? Yes. Do we see every group of 2/3 represented there?
Yes.
Yes, this is a direct modeling strategy. Look at the math that's involved in this early level strategy. It's like, oh no, she's got to be way over on the end of the continuum, right? No. But because this is so different and such understanding here, it's really early understanding that has a long way to get to grow and develop. So this is still, it's just like, or very similar, although she's not using a picture. She's very, you can see where it would have come out of a picture where she would have drawn and kept track. There's one cake, another cake, and then this one and this one can go to the next cake, right? Right. So she's moving away from needing a picture and able to think about them with numbers, but still needs to see the 1/3 there with the 2/3. So for the next one, before we see, we're not going to see a video, we're going to see some student work. But I want you to think about this problem and a gecko problem about gecko. And this is true, geckos eat baby food. If a gecko eats 2/3 of a jar of baby food a day, and we're all going out of town for 15 days, how many jars of baby food will the gecko eat while we're gone? Okay? So think about the kind of problem it is, and not solve it with a direct modeling strategy, but what would a repeated addition strategy or counting adding strategy look like? Now remember, counters and adders, do they need, if that middle strategy, counting and adding, do they need to see the 2/3 and the 1/3? No. They can operate on the 2/3 by itself. But you're going to see every single group of 2/3. So try to predict what a repeated addition strategy would look like for this.
Family total multiplication.
They can pull 2/3 out of the whole by itself, and they don't need to think about it in the group of 3/3. How any child that would fit in the category of repeated addition, what their strategy might look like, because they can look a little different, but we're going to see every single group of 2/3 represented, but we're not going to need to see that it in a whole by itself, you know, along with the 1/3.
Because you're not having to put it at 2/3 at a time.
You did this 15 times.
Oh, I see what you're saying. Well, not easily sharing.
At some point, having recognition.
So we saw a direct modeling strategy for this. It was 9 groups at 2/3. This is 15 groups at 2/3. But what would a counting adding strategy look like? It's a little more sophisticated. Yeah, counting adding or repeated addition is one way we can think about it. Not what a kid's good.
Well, this is one of the things about Cloud Box. That 45 thirds.
This isn't a strategy you see kids use. So you can come up with a strategy kids might use.
All the way over until yes, which is what
If you got an answer of 30/3, some kids will do that, but I want to challenge you, what's another way you'll often see kids do? I see a lot of 30/3, but you're going to have lots of other ways other than figuring out 30/3 and then changing it into wholes.
So you added this. That and that plus one utility.
Unless they model.
Often do other types of. Oh, you all these ones? Yeah. 1/3. No, not
How would you do there? How did you know? I'm hearing but I want to show me folders. Is this show me tell me something about dividing. Is that? Told you about my because I was working on George, right, was thinking like 6 and then I stopped because I had a whole that's what we talked about, didn't we? George.
And because there's one button in front of them, she didn't think that. And then back to Kid would do it.
I'm gonna try to
Okay, reset it. It's all done. There's plug it into a motor. There's the whole.
But she was not shown how many times would they, how long would it be before they figured out those three names? How many would they have to count to figure that out? Yes, because we would split, we split the 2/3, so 1/3 for that one, 1/3 for that one, so that's 2. 1/3 for that one, 1/3 for that one, 2. Yep.
Another way is like, you're not in the environment. Like I can 6:30. Jeffrey will be in the 50 plus car every 3 of them. I can circle in that's 2. This seems you are doing this on the fast track. Wait a second. There's my selfie every time.
What are you doing on the bench in pantry?
I know it is. So we use the
Freezer? The freezer. My freezer. I go back to the bottom of the shelf. I'm in front. The top shelf is chicken. The next shelf is beef. The next shelf is pork. The last one is fish. Right? It starts to get empty. I gotta go.
And then they got the feed off and
but I did find
All right, so let's, I asked a couple of you to share, and would you share that one? You can zoom it in. Let's see, you think I know? Okay, there we go. And then the little dial will zoom in. So zoom in on your little square there. No, zoom it more. Yeah, that guy. Keep going. Nice.
All right, the gecko eats 2/3 a jar a day, so they're gone for 15 days, so I put 15 2/3 because that's how much the gecko's going to eat. And then for me, when I hear skip counting or repeated addition, I think of groups of 2, like 2, 4, 6, 8, 3, 6, 9, all that. So I put them into groups of 2, and so 2/3 and 2/3 is 1 1/3, and then I did it again for all of them until I had this one left over, so I just left it and with it. And then I still had a bunch of numbers I didn't know, so I skip counted them again. So the 1 1/3 and 1 1/3 gives you the 2 2/3. And again, I had that one left over, so I just left it alone until the end. And then I finally got to the very end where I had no more skip counting or addition I could do, so I had the big problem of 5 1/3 plus 2 2/3 and 1 1/3 and 2 2/3. And you add it up, you get 10 jars. I didn't solve it, but then I would have gotten 10. So I tried to take a step back because my first thought actually was, hope I'm not to anybody else's, is we did put them in groups of 3, put them straight into like last 2 jars. But we realized that how many kids, we realized how many kids would actually do that. They probably would go just with the 2 first, so we took a step back.
So you said a lot of nice things there. So, so this is more typical of what you're going to see early on, especially with this number of 2/3. So it's counting and adding because we see 2/3 all by itself. There's no 1/3 that has to sit there with it. And then so it's this idea of doubling. right? So I double every 2, and then I double the double, and then I have this, in this case, I have some extras. Now, if we had put 16, then we wouldn't have had as many extras. So you can purposefully make it icky, right? 15 groups, get you to have to combine some nice fractions. How am I going to combine 2 and 2/3 plus 1 and 1/3 plus 2/3 plus, you know, so all those pieces are nice. So this is very typical strategy. What you'll see is kids will double. And as he said, when you double, you don't come to a nice whole number with 2/3. But when might you? What fraction would you double that you would come to a nice whole? Halves. Just combine 2 of them. Which one's going to give us a nice whole number? Or something a little nicer, I guess, when you double. 3/4 and 3/4 is 1.5, and this is 1.5, and then 1.5 and 1.5 is 3. So you can find which fraction, when I double and double and double again, might land on a whole number. 1 1/4 and 1 1/4 is 1.5, and if you keep doubling, so play around with the numbers, okay? So we see every single 2/3, and it's sitting by itself. It's not having to be in the whole. So was there another? Who did the thirds? Who did the 3 groups of? Yeah, you want to come show that?
Sure.
So I said the same thing. I mean, they would write it all out, and then they would combine them, choose their normal. But I thought if they could see 4/3 as 1 and 1/3, then I thought they were pretty proficient at thirds. So I thought maybe they would actually see a third, and a third, and see that it's a whole. So I pulled the whole out, and then the last 2 would be combined. Then again, if they saw the thirds, they would see the third and 2/3 as a whole, and they would get the 2.
So she started with doubling it, but then maybe somebody would say, hey, there's a 1 and 1/3, 1 and 1/3, 1 and 1/3. That's 4. And could begin to use that grouping. I've also seen kids, you can leave that there because I'll use your work, and it's kind of a play off of what you were messing around with over here. They'll often look and say, well, I can take a third from there and make a whole, and I can take a third from there and make a whole. So with 3 of these guys, I can make 2. So you'll also see them begin to just move to make a whole from another. So they're beginning in now to do that grouping. Starts with just doubling at first, but then it can get bigger groupings, and that's what that's the thinking that's gonna take them over into relational thinking, is finding that grouping that I can either keep adding or can multiply. They might also do, oh, I think the thing asked you though, I don't want to get ahead of what. So here's a sample of what Madison did. With 3 of her student work. So she did 4/3 and 4/3, doubled it that way. And then her 4/3 became 6/3, and what did her 6/3 become? I mean 8/3, and then her 8/3 became 2 and 1/3, so she kind of trickled down in this different way. So, but the key mathematics here is we see all the 2/3 represented, but they're standing alone without the 1/3. So the way kids combine them are going to bring out nice discussions in the classroom. Okay. So now I want you to try not a repeated addition, but I want you to try a skip counting, and try a couple different ways of skip counting to solve this problem about Kenzie drinks 2/3 cups of water every mile she hikes. If her water bottle holds 4 cups, how many miles can she hike before her water runs out? So try a couple different ways of skip counting. Not repeated addition, skip count. I mean, not doubling, but skip counting. 5, 10, 15, 20.
What's the difference between a skip count and skip count? I'm just having a difficult time with that. I don't know. What is the difference?
What do you? 2/3 going 1/3 is 2. So 2/3 is 3. So I didn't really. So what is it?
I guess to get the kids started.
You know, to give her the
Keep going.
Yeah. She's just gonna realize. I forgot
Okay, see if you put your neighbor's have as you do.
I just want you to keep after 2/3.
But what you need to do
Then how do you interpret the you did it 6 times.
What about this? Not about this. And you go 1, 2, 3, 4, 5.
Oh, I started adding 1/3.
What's the answer though?
So then I could do it. 2, 4, 6, 10, 12. And I can't get the right answers now?
Trying to make light. What to do?
What's that mean?
Go shopping with With this one,
I like this. Yeah.
My heart warms to see you guys engaged in skip counting in 6th grade. I'm excited, right? Yeah. So, oh, questions?
Well, I just wasn't sure if what I did actually ended up as being skip.
Well, we'll look at a couple examples because it's not going to all look the same. Kids will do it in different ways, but it'll have the same mathematical characteristics. We're going to be able to see that every 2/3 was acted on individually, but it was able to be standalone, not have to have the 1/3. So tell us what you did. So remember the story is I have 4 cups of water, and every mile I drink 2/3 of a cup. How many miles can I walk before I'm out?
Okay, so I'm really loud, so I don't need to do that. Yes, I am.
For what?
Okay. So I started by saying.
What do you want to do? Let's make sure it's the right magnitude, because I think your hand was going out.
Okay, yeah, I will. The kids always say, please go.
And you can.
Okay.
You can dial.
So I started because I needed 2/3, right? So I went 2/3.
So dial it out. Okay, there you go.
2/3, and then I go, okay. I went 2/3, and if I skip count, then I'm going, okay, the next 2/3, I would have a whole and a third.
Okay, stop. Everybody agree? Yeah. So 1 group of 2/3 is 2/3. 2 groups of 2/3 is 1 and 1/3. Kids may think about it's 4/3, or at 2/3 I can move 1 over, right? Make a whole, and I have a third left. Okay.
Okay, and then the next one was easy because it was 2/3 and a third, so I have 2. Okay, and I go, okay, well, what do I want to be? I want to be at 4, so I'm going to go, okay, 2. That next one's easy, 2 because it's 2/3 again. 2 and 2/3.
So our skip counting game from the other day, right?
Okay. Yeah, and then again, 2 and 2/3, I'd have another whole. So it'd be 3 and 1/3. Right? Am I right? And okay, and then if I add, then I'm at 4.
What do you mean she's not there yet? Somebody said she's not there yet.
Okay, so now I'm at 4, and then I go, okay, I'm at 4, but what do I do? And I go, oh, now I just need to know how many, so I went, this is 1, 2, 3, 4, 5, 6. So I can go, I think it was 6 miles? 6 miles with my water. And I'm really tired.
Okay. What might you ask here of a child? Yeah, what does 1, 2, 3, 4, 5, 6 mean on your paper? Any other things? What else might you say? How'd you know when to stop? Right? For kids that are direct models. Yeah, you're not at this place, you're a direct model. And not only are you asking this question, you might be asking them to kids that are direct modeling, because now you know this is their next step. So if Steve, are you Steve?
Yes.
If Steve's a direct modeler, so if Steve's a direct modeler, I may be saying, Steve, where's the 1 and 1/3 in your picture? Where's the 4 in your picture? What do those numbers do you think mean? Because he's looking at this as his next place is going to go. So we're going to want our direct modelers to really be paying attention to the counteradders, right? We're going to count them. So there's another thing that you can do is you can pose another story right now. So what did we learn, you guys? Oh, with 4 cups of water, he can go 6 miles. What if he has 12 cups of water? Put your pencils down, don't do it right now. What if he has 12 cups of water? See if you can do that in your head. You guys all try. So we just found out with 4 cups he can go 6 miles.
All you have to do is take
4 to 6.
So what if I have 12 cups? How many miles can I go? 18. How do you know?
By 3.
Multiply by 3. Why?
Because 12 cups, 3 equals 4 cups.
Yeah, why'd you multiply by 3?
Because 12 cups is 3 groups of 4 cups. So you have to have 3 groups of 6 miles, which is 18 miles.
So for 4 cups is 6 miles, and then another 4 cups is 6 miles. How many cups is that?
12 cups. 12
8
miles.
cups,
12 miles.
right?
12 miles.
And then another 4 you said is our 12 cups, so we have 6 and 6 and 6, right? So slow it down and get everybody on board, because that's the thinking they need to do to go to the relational thinking. So you're letting them mess with it. You already got here. You could just say 8 and make it, you know, yeah. But if they need to begin to think more than just double, 12 would be nice with this one, or 20 might be nice with 5. So some are going to say things like, well, 4 cups will go 6, 8 cups will go 12, 12 cups will go 18. Some are going to say, I just multiply by 3. I don't have to add those chunks 3 times. Why are they multiplying by 3? With this story, why?
Because the fraction is thirds.
Oh, give me rules. I have 4 cups of water, now I have 12 cups. What's the relationship?
4 times 3 is 12.
What's the relationship? I have 3 times as many cups of water, which means I can go 3 times as far. Get that language out of their mouths. Work on getting that out of their mouths. Because the kids understand, why don't you just multiply by 3? The others are going, all right, whatever. Go back and find the drum, you know, so slow that down, because that thinking is worth time, right? Now we can see that thinking is worth the time it takes to slow it down, get everybody on board. Yeah. Now the next problem, some of the kids might use that, some might not. Teachers might even say, well, you guys have been solving problems where you've been getting to these nice friendly numbers. I wonder if there's a place in this story that when you get to a friendly number, you can maybe stop and figure out some things in your head. And try it. If not, keep going. So you can plant when you think they're ready, not direct modelers, they need everything there. Don't ask me to do that, or I'm going to feel like I'm bad in math and you don't care about my thinking and I'm out of it and bye. It's where I've always been. I've never understood. Here I am again, right? But when it's time, you can ask a few kids, you can look around and go, oh, you got to 4. You got to a nice friendly number. I'm going to come back in a few minutes, see if you can figure out, using what you know, and talk to them. What does that mean? Then see if you can do the rest in your head. Call me back over. You can do it individually to kids as you're walking around, and not do it to the direct modelers yet. We just want them to do some skip count. So here is Amy's. Does it look familiar? Oh, see. There it is. So they're keeping track of 2 quantities. It's a tea table, right? It's a tea table. Or I don't know what they are called now. I think it's called something different, right? function table. I don't know, is that too fancy of a thing to say here? But, so they're keeping track of two quantities, total number of water used, miles. So they're keeping track of these two quantities in different ways.
Sixth grade teachers, you might want to pay attention to that's a proportional relationship as well. Your sixth grade kids need to be able to defend why that's a proportional relationship.
And they won't realize that until they say, when you say to them, what if you have 12 cups? And they multiply by 3. They don't realize it until they use that multiplicative thinking. Right here, it's just kind of additive still. But it's exactly what Carl says. You put in the 12 or you put in the 20 and somebody goes, times 5, there it is. Because proportions are all multiplicative. They're not additive. Doesn't have to know that 4 plus 8 is 12. I have to know 4 times 3 to solve it proportionally. Okay. So we're going to take a look at Diego. And Diego's solving 10 pizzas, and there's 3/4 of a cup of pineapple on each pizza. How much pineapple did you use? So how much is 10 groups of 3/4?
I was going to say, didn't we just do that?
I can't do it because I know they're not the way they do
Hey, remember Diego? He's our 1/10 guy. He still has a little bit of
Alright, so you want to read this story?
Okay, my story is make 10 pizzas for the class. She put 3/4 of a cup of pineapple on each pizza. How much pineapple did she use?
Think you understand the story?
Mm-hmm.
Okay, let's see if we're going to solve it.
Okay.
How much is 10 groups of 3/4 is what it's solved. You've got to keep that in your mind.
Questions? How many?
Now, 10 groups of 3/4. Trying to keep track of. How many course have I done? Because they're not all there to touch anymore.
Probably trying to count the tens of them. It's hard to count with your fingers when you're driving.
Seven and 1/2.
7 1/2, 7 1/2.
Huh?
7 1/2.
Oh, pineapple.
You want to write that down on your paper?
Yeah, so it's Brian.
So this is 7 1/2 of pineapple. How much pineapple are you talking about? What do you mean?
7 whole and 1/2.
7 whole what?
Pineapple.
A whole pineapple?
Yeah.
What does that 7 1/2 mean in our story?
That's how much pineapple she used for the pizza.
How much pineapple she used for the pizza? Okay, so tell us what you did.
So I added 3/4 and 3/4, and I got 1 and 2/4. So that was 2 pizza, 2 times. And then I added 1/4 and 1/4, and it equaled 3, and that was 4 times because 1 and 2/4 is 2 times. So if you add both of them, it's 4 times, and you add them.
So what's that 4 mean in the story?
That she used a pineapple 4 times already.
So she's used 3/4 of a cup 4 times already?
Yeah.
So how many pizzas has she made already?
She's made 4.
4 pizzas, and how many cups of pineapple has she used?
She used 3. 3 whole cups. And I added 3 and 3, and that was 8 cups. So, and I got 3 and 3, and I got 6, and that was 8 cups altogether.
So come back here again. 3 and 3 equals 6. What does that 6 mean in your story?
That's how much pineapple she used.
So 6 cups of pineapple. How many pizzas?
8.
8, okay.
And then I added 6 and 1 2/4 because that equals 2, and I needed to use it 10 times. And I got 7 and 2/4.
7 and 2/4, okay. And then your answer is 7 and 1/2.
Oh yeah, because 7 and 1/4 equals 1. 7 and 1/2.
How do you know that?
Because 2 is half of 4.
2 is half of 4? So if I write, can I write something on your paper? So,
Said 2 is half of 4, but I want to check the relationship. And this.
and tell me why you put that there.
Because I know 2/4 equals 1/2.
I want that out of his mouth instead of 2 is half of 4. All right, top of your table. And see if you can figure out what his strategy was to figure out how much.
I can sit here and I can sit and I can see what kids are doing and I can do that. And then if I have to sit there and go, okay, yes, skip the link, yes, multiplicity, I have to
It's all useful information. It's all useful information that's taught based on what you
Do you guys have intervention? We don't. It's our process. Does that take tests?
I start off drawing.
We have felt where we don't need that. We're going to teach her and shove all these that are not practical on any reality. And then we wonder why the next Is there a website? I know we asked this is there something you can't so they can go and solve in years or whatever these word problems. Is there something like that so we can teach those songs? But not in the book. So when we have lab and we, you know what I'm saying? We have model, so we think about that on the desk. But I'm saying there's a non we've got that time here specifically math, which is right. They can choose or pick their question, right? Which they would have paper. But I'm saying, yeah, just the question, so that they have a multitude to pick from, and then you know, go to 17 or whatever. So 4th, 6th graders, little kids, 4th graders would be hard them out. You know what I'm saying? Different levels. And that's okay, because they need all levels, and we're going to have my name.
Hello? So do we understand the strategy, Diego's strategy?
You're smarter than me. So they're trying to crack that.
So it's not direct modeling, right? He is doing some adding. Is it a counting adding strategy? Well, let's go back to our criteria. We know he's not having to show the whole, right? So it's not a 3/4 and a 1/4. So it's not direct modeling. So does he, the next criteria is, are we able to touch every single 3/4?
No.
No, they're hidden. They're all there, but they're now hidden in groups. Groups that are going to let him later use the distributive and associative property. So, it's not a counting adding strategy, it's relational thinking. It's the beginnings of making a group. And so when we think of the distributive property, it's always about 3 groups of 10 plus blah, right? The associative property, 4 groups of 3 groups of. So those 2 properties demand us to think about individual numbers as a group and to think about group totals. So he's at the beginning of just doubling. He's just not doubling every 2, but I double 2, and then what? Double that, and then double that. It's kind of exponentially growing, right? So it's a different kind of double than we see with counting and adding, where we have all of them and we double, 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 and double, 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 double. He's doubling 2, and then takes that new group and doubles that, and takes that new group and doubles that. It's called complex doubling, but it's a form of grouping. So 2 3/4 are 1 and 2/4. Now I have a new group. 1 and 2/4 and 1 and 2/4 are 3. Now I have another new group. 3 and 3 are 6. Now I can't do it anymore because I'm keeping track of 10. So it's different than the doubling that kids are going to do in counting and adding. It's creating these larger and larger and larger groups, using the group I formed to double. So he's kind of keeping track in his head and on his fingers where the 10 is, but you'll see kids write little numbers under there, that the 3 means what? The 3 means how many groups? 4 groups, right? The 6 means 8 groups. So you'll see kids write little notations on their paper to keep track of the 10. He does in his head, but you might, if you're sharing his, you might have to, help kids slow down where are all the 10 groups, because we can't touch them. We can't touch them like we could with Maddie or Divine or Sarah. We can't touch each one, so we're going to have to go searching for them. Yeah. So one more that I want you to play around with, and that is, besides just this doubling that Diego does with this problem, which is nice, and it's a start, doubling, kids start there all the time, what other grouping could you use for this problem? So play around with that. What other grouping might kids use?
Besides starting with 2 groups, what other grouping might you start with?
The next one.
Don't start with doubling. We already started with that. What other start do you get?
Another way of doubling.
Other than doubling. Another grouping other than doubling.
What's another way to group it?
That's what my brain went. I was like, you get double 1. You get 2. Double again is 4. Add the 1 on. That's for white. I'm thinking double. If I got but he
whoever passed out was just the exact amount. So she
I still think 4 is fine. If it comes to an even number.
that was just
He started out, but he had 2 of them. Double counting that 1. I would think the business when it's combined quantity and
Good deal. When did that start? Right away, the beginning of the year? Yeah. You did the ball? It's got to be good basketball. Do the ball chain and do my
so that's something because I need to take the stuff from my house back into my class.
Okay, anybody want to share what other
better than
what other grouping other than starting with 2 3/4 kids might do? They might start with 3 3/4. What do you get when you put 3 3/4 together? 9/4, 2 1/4. So they might. Anybody else play with another one? Why might they do 4 groups of 3/4? Okay, so this is the last big challenge I'm gonna ask you to do, but I want you to think hard about this one. So why would kids eventually do 4 groups of 3/4? Because you said it would get to a whole number, right? How do they know that? Why would they purposefully take 4 right off the bat? You can't say because they're going to know it's 12/4, maybe, but then they'd have to have already tried it, right? How do they know right away that 4 groups of 3/4 is 3?
Oh, because 4/4 is 1. Okay, so 4 is 1, and 1 times 3 is 3. Yeah. That's what I mean. Good job. Because 4/4 is 1, and 1 times 3 is 3.
Something that the course goes into, so 3/4, you can't get the nice function.
Yes. So they're somehow going back to their unit fractions.
How do they start beginning?
Somehow. Of creating a whole. Creating a whole. They have 3/4 not a whole, but 4/4 is.
So therefore, 3/4 times
Have a knowledge of cubes. I need to get
because they've already established earlier that 1/4 times
Babies.
But if maybe you could create the
Yeah, that's the numerator times the numerator. They know that 1/4 plus 1/4
He wants to create a whole. That's the unit fraction to make it a whole.
And I read so fast
We don't think that that's what we're doing when we do that. We're just like, boom. That's the process you're going through, or you had to go through to have that understanding.
So, how are kids thinking about this? Why do they know to take 4 groups?
They're associating.
What's broken up into 4s? So this is broken up into 4s? Okay, so is that what you're kind of thinking?
Well, just the 4 in general, like it's 3/4. So with the cup of pineapple, it's 3/4 of it. We kind of played around with other numbers to see if it always works. So we did, like, what if you had 12 groups of 7/12?
Okay, hold on. You're doing my second page, so let me put it up here. Let me see if I want to mess with this first. I'm going to ask them to mess with this first, and then we'll play around with it. Does it generalize? If it generalizes, we want to grab it. You're going to read an article. You're going to read an article. Carl will tell you more.
Yeah,
It doesn't.
I'm going to stop you in 10 minutes. So.
If it doesn't generalize, we don't want it. It's not useful. If the mathematics that kids are using doesn't generalize, it's not going to be useful later on in algebra. Or in other situations. It's good for right now, and that's it. You changed it, the situation, and I can't generalize it to anything more. So that's what they're playing around. Does it always work? If it works always, grab it for math, right? Okay. So come on, because I don't want to.
This problem?
Yeah.
Okay.
You want this?
No, I don't think so. I can talk about it. My thought was looking at the 4 and the 4 since they were the same. Thought, well, I kind of went to my higher level math of cross simplification. So if you were to make it 4/1 times 3/4, a lot of you probably teach your kids eventually that you can cross simplify with fractions, and then this would turn into your big giant 1. And so you've got 3/1, which was our answer of 3. And so we kind of took that process of the denominator kind of told us that we want to break it up into fourths because it makes that nice giant one that the students, at least I like to draw or write. Did that help at all, or did that kind of...
I'm going to add a little bit.
Okay, good. I needed my generalization to help, but that's how we kind of got this. Was we didn't quite solve it from directly this one problem. We had to make 3 or 4 until we realized that it worked every time.
But you gave us a nice thing to start thinking about. So he said, if I think about 3/4 as this grouping of unit fractions, what can I think about? And you guys were messing with it too, why don't you?
Well, we went back to 4/4 is 1 whole.
So this?
Uh-huh.
There's that fundamental understanding, right? So hold on. So if I know this fundamental idea, how is that going to help me up here?
Right. So then if 4/4 is 1 whole, then 1 times 3 equals 3.
So I have this guy 4 times, that's 1. I've got this guy 4 times, that's 1. I've got this 4. So I have this guy how many times? 3. And what is this guy? 1. So what they're really thinking, and this is what's so fascinating, is kids' higher level strategies as they build they naturally come very close to the traditional one, because that's where the traditional one came from. It didn't happen in one generation of mathematicians. It happened as people thought and thought and thought, hey, and it got more abstract. But it started with just pictures and things. So they thought, kids are thinking about 3/4, how? Maybe it's 1/4 plus 1/4 plus 1/4 early on, but then they're going to be thinking about it as 3 groups of
1/4.
So is this still 4 times 3/4?
Yes.
Is it?
Yes.
Yes.
There's 3/4. 4 times 3/4, right? Still there. But now what can I do?
Switch to 3 and 4.
Yeah. I want to do that because it gives me 1. Then what do I have left?
3.
I never thought of 3/4 like this. I've always thought of it as 1/4 plus 1/4 plus 1/4. But kids begin, as you can see, as they're thinking and making groups, they begin to use this idea along with this idea. So now they want to play with it, generalizing, right? So give us one you tried. I'll put it up here.
8 times 5/8.
8 times 5/8. So think about that. What's your foundation? 8 times 1/8.
Right. Times 5.
So 8 groups of 1/8 is 1. 1 times 5 is 5.
One fraction. Lose your 5.
That's why the cross cancellation works. Kids are discovering it as they're developing this rich understanding. And it's not, the fundamental was 8 groups of 1/8 is 1. And that starts all the way back in equal share. So we're beginning to see this long continuum over a year or multiple years that kids can develop this kind of rich understanding.
Which is the same thing as 5 times.
Want to try one more? Here, I'll give you, let's do this. How many groups of what times 11/15 equals 11? 15 groups of 1/5 is 1. So 15 groups of 11. 15s must be 11. No need to put a 1 under it, cross cancel. All I need to know is what's in my 1. And what does 11/5 really mean? So you can see that out of language, that traditional instruction, 11 out of 15. How am I going to use that thinking? It's not going to do me any good to think of it as 11 out of 15. I have to think about it as a quantity, 11/15ths. And that's 11 groups of 1/15 to be powerful with this. I am looking forward to looking at your post-assessment. You're going to rock on your post-assessment. So I'm done with you guys. I've enjoyed sharing my passion for children's thinking, and I hope I see it stirred in you. Thank you for your professionalism, your hard work, and being willing to take risks and feel uncomfortable. And I look forward to maybe even coming and visiting when you get to do your CGI embedded days. So with that, I'm going to turn it over to Carl. He's got something to...
Thank you, Ruth. I actually learned a lot listening to you. I'm not used to that, sorry. As we move toward thinking about what this is going to look like in our classroom, I've listened to a lot of conversations, and you guys we've really stretched you. Instead of thinking about what I can tell kids, we're now thinking about what can the kids tell us. That's a big step, right? And taking what they know and learning how to build on what they know is a lot different than we've ever done. And to help you down that road, we have an article. And if you guys are online and are on Google Docs, I've loaded this. I put a folder in there, and I'll show you where it is after lunch. But if you want to go searching for it, I put all the any PowerPoint I used this week, I stuck in that folder. And I put 2 articles in that folder. I also put just a blank document, I shouldn't say blank document, just a Word document that has some of the resources that I go to, the places where I want to go for inspiration on the internet, websites. I put about 10 of them on there that are my go-to places to go looking for good resources. I figure since you're going to be looking for resources for lessons, you'd want to be able to click through those. I put them in a Word document so that you can literally just hold down Control and click on it, and boom, it opens up. So I loaded that there, but this article I want to share with you is electronically there in case you want to share it with your peers at your school site. This article creates some controversy. And so just to give you a little heads up, if you leave it out on the coffee table at work, you might get some people mad at you. It's called the 13 Rules That Expire. And I guarantee you there are a lot more than 13. This is a sample. And really what they're talking about is we teach kids algorithms at times. And when I say algorithms, I don't mean just formulas. I mean things that we tell kids that aren't necessarily true. Pass them that way too. We actually lie to our kids sometimes. And I don't think we do it on purpose, but we do. And this kind of calls some of those out. And I want you to know that the kindergarten and coming, they're moving around. There's plenty. If there's extra house in that table back there, so a couple of them that you might be looking at and going, really? In 2nd grade, when they first start doing subtraction, 1st to 2nd grade, one of the things that those teachers say to their kids is you always take the smaller number from the bigger number. You know, and for you guys in this room, I bet you wish they would stop doing that, right? Because that leads to a misconception. Always take the smaller number. That's not true. Another one that's in this article that just drives us all nuts down the road is if I multiply 2 numbers together, my product is always going to be bigger. That is a lie. You tell your kid that's a lie. Because if I multiply 20 times a half, my product is not bigger than 20, right? I mean, it's smaller. And if I multiply a half times a fourth, that's really smaller, right? So, I mean, when we tell them things like that, we're leading them down the road to misconceptions. So there's 13 of them in that article. And I want you to know the other 2 rooms have had this same article. And it's created some interesting conversations with some of those K1 teachers and 2, 3 teachers, things that they've always told their kids. And there might be some ones in there that you guys have said to your kids. And I'm going to share the one in here that's probably 5th grade-ish. And I'm going to share it with you because of the fact that I see this as a huge, when I work mostly with secondary kids and teachers, I walk into secondary classrooms and I see huge misconceptions that kids have because of this.
Really?
It's not that it's bad. We have to be careful about the way it's used, and it leads kids down paths that we probably shouldn't take them down. And so I want to explain where some of the misconceptions are in here. And some of the misconceptions might happen you might see it happening in your classroom just because of this. When I see this, if I'm following this, I'm looking for parentheses first, right? And then I'm looking for exponents, and then I'm looking for multiplication and division. Hopefully they see that bar is a division bar, right? But now I have a problem. Do you see the issue here? That division bar is actually a grouping symbol. There are tons of grouping symbols that your kids are going to come across as they get more and more advanced mathematically. That's the first one they're going to see, is that fraction bar is a grouping symbol. Parentheses are not the only grouping symbol. It's one of many. And this leads kids to thinking that grouping symbols. But then you have to, then the problem is you teach them the grouping symbol that's appropriate for you, and then the next year they get more of them. And so
let me just ask, in this article, does it give us an alternative way of teaching it? Because I know, like, in my 4th grade book, there is order of operations.
Yep.
So now I'm going to want to avoid this acronym, but then how?
So
does it give me how to teach it now?
Here's how I would explain order of operations to kids. I don't do gems either. Here's what I tell kids when we have this conversation, because a lot of times kids get to middle school and high school and they're actually broken when it comes to this. So we have a really frank conversation about how is mathematics built. And I take them back to 2nd grade. When you're in 2nd grade, what's the first grade, maybe kindergarten? What's the first operation that you learn? Addition. You learn to count, and then once you've got counting down, then we learn to add, right? That's the basic building block, is adding. And so I can add 2 plus 2, I can add 2 plus 2 plus 2 plus 2. I can add things together really well. Subtraction actually is addition. Subtraction is addition. I'm just adding a negative number. So you teach them that addition and subtraction are really the same operation. And in fact, in some math classes you take in college, there is no such thing as subtraction. So addition is where you start, right? And so when you think about it, that's our basic building block, is addition. If I want to repeat addition over and over again, if I want to go 2 plus 2 plus 2 plus 2, it gets really old after a while to keep counting skip counting by 2s. So we learned at some point, maybe in 3rd grade-ish, that if I'm going to count a whole bunch of 2s, that I can shorten that into multiplication. And again, there is no real division because I'm just multiplying by the reciprocal. So in a lot of math classes, we don't even talk about division. We just multiply by a reciprocal. So after we've learned to multiply, or after we learn to add, we repeat that addition, and now we're at multiplication. And division is just multiplying by a reciprocal.
As an adult, if I go to the grocery store and there's 4 of us, And I want to make sure everyone's getting to share. I don't multiply by reciprocal.
Well, but that, you teach them that division is the same thing though as multiplying by the reciprocal.
We teach fourth graders that division.
You just did it a second ago. You did it all, you do it all the time. The problem that Joan just did with you a few seconds ago, which was the one that she had up here? 8 times 5 eighths, right? Here's what you really did. You had 8 times 5 eighths. You really did this, 8 times 5 over 8. Right? I'm not actually doing division per se. I'm rearranging things.
Once I do the 8 times 5 over 8, I'm then going to have to do the 5.
Now I'm going to switch these 2 around. That's okay, right? That's just the community property, right? So now I have 5 times 8 over 8. I didn't really change anything, right? And now I can pull that 5 away. And I have 5 times 8 over 8, which is the same thing as 8 times 1 over 8, which is a reciprocal. And there's my 1. But we want kids to see that reciprocal is the same thing as dividing. Multiplying by reciprocal is the same thing as dividing. And where you teach it, whether it's 4th grade or 5th grade, I'm not sure exactly where that's going to fall for kids. But teaching just some mindless acronyms sometimes leads to misconceptions down the road. So we start with addition, we repeat addition, we get multiplication. Now I got multiplication, I go 4 times 4 times 4 times 4 times 4. That gets annoying too, right? So now if I'm going to repeat my multiplication, I now have exponents. And now the only way I can change that natural order of things, that natural flow, is by using some kind of a grouping symbol. Right? I can use parentheses, I can use a square root, I can use a division bar, whatever I want to group, but I can group things using some kind of a grouping symbol. But that's the natural flow, is I start with my basic building blocks of addition, I move to repeating that and getting multiplication, I go to repeating that and getting exponents, and that's that natural build, right? So then if I'm undoing something, I start with the exponents and go to multiplication and then to addition. Does that make sense?
I'm still just at that point where I'm thinking of that lesson, and I'm thinking, okay, they're going to give my class this long, with many different symbols, and they're going to say insert the parentheses so that the answer would be 6.
Right.
So then, how, without using PEMDAS, am I going to teach them?
And I'm not saying you can't use PEMDAS as long as they understand.
This is not going to work in
real understanding the exceptions to PEMDAS. I sit in high school classrooms and I sit next to a little freshman that sees this string of numbers. It sees this 4 times 3 minus 2 plus 6. And this is a 14-year-old kid. And you know what he does? He sees addition comes before the subtraction. So he adds these 2 things together.
No, these things that I usually depend on the first grade teacher. I draw a little arrow with the M and the D and the A and the S, and I say whichever one comes first.
But here's another thing. Wait. I know we get huge controversy when we start talking about these things, but this whole thing of moving left to right.
It's not so much left to right. For me, it's, okay, take that away, but now tell me how I'm supposed to do it so I do it right.
You let the kids play. I mean, the thing is there is a natural order. They'll see the natural order, right? And you don't have to have an acronym for it, but if I do this, if I go 12 minus 2 plus 6, is 12 minus 2 and then plus 6 the same thing as 12 minus 8? It's not the same thing, right? Why aren't they the same thing? Let's talk about it. I mean, when I work on this problem, I've got one subtraction and I've got an addition. Does it matter the order they go in and why? That's that huge question that kids have to grapple with. Otherwise, this is just a memorized thing that they're going to misuse down the road somewhere.
Right, so I mean, I have my heart is not attached to PEMDAS whatsoever. I don't care about
just want a way to be able to explain to you.
Show me how to do it right. And, you know what I mean? Like, it's not really a controversy for me. It's just like, okay, if this is the wrong way, show me the right way.
What he's saying, I think you have to
Be careful not to lead kids down a rabbit hole with it.
It's just like the English language. I mean, you teach kids this school is going to lack, is going to work 80% of the time, but there's always an exception.
I think because in math, sometimes the problem, it's not that. I have no doubt that you guys can work operations. You say from left to right, in the order that they show up, doesn't matter which one comes first. I teach adults at the community college, Alpha 1 and Alpha 2, and I never use PIMDOT. I never do any of that stuff. I give them their assessment, and one of the first things goes on top of their test, PIMDOT. And I can spend a week saying grouping symbols and all the different grouping symbols and all of this and they write PIMDOT and they do it all because NDAS implies an order and they follow multiplication, then division, then addition. I can say it a million, but sometimes it's not that we didn't say it. We gave them something quick to remember, and most people who are fearful of math, they'll cling to that fast thing so I don't have to understand because now I have something that will just tell me.
So we're just saying that we have to be careful not to get kids dependent on something that
to get dependent on that. I think that's the word, to get dependent on it.
And I have to tell you guys, I have a whole bunch of nieces and nephews, and as they've come up through school, and we're talking lots of different school districts and lots of different schools. With glasses.
Show us.
Here's what she gave me, 14 plus 16 divided by 8 minus 6. So I'm going to come back to this one in just a second, but I always pose a simple question to my nieces and nephews as they're going up through 3rd, 4th, 5th, and 6th grade, because I just want to know mentally what they've been taught. And I pose this question, I pose the same question to every one of them as they come through. I say, what is 97 minus 15 plus 3? Just to see if their teacher has ingrained in them PEMDAS and whether they can think. Now, you and I in this room, we do not subtract 15 from 97. I hope you don't. I hope you look at that string and see 97 plus 3 makes 100. And you put that together first. And then you take the 15 off in your head. And that, I did not work left to right. I took the two numbers that I could mentally put together, and then I took off the number that was left, right? And I want to know with my nieces and nephews, and I have to tell you, I have a bunch of nieces and nephews, a bunch of them. None of them have ever done this the way I would want them to do. All of them have gone like this. And then they get their answer, and then they go plus 3. I want kids to be flexible thinkers, right? I want them to understand numbers and be able to use those numbers in a way that makes sense without having to be stuck in an algorithm. I keep seeing him.
Oh, sorry. I was just going to say, and I hate to burst some of your bubbles, but Santa Claus isn't real. But it's okay for my 7-year-old to keep believing that Santa Claus isn't real. It's also okay for him to think that subtraction is real as well, but at some point he's got to change his thinking.
And eventually he's going to get negative numbers, and those negative numbers can be thought of as adding, in fact, a lot of times it's easier to add a negative than it is to subtract. So let's look at this really quick before I get too far. I got 14 plus 16 divided by 8 plus 6. So we're looking at those numbers and we're thinking order of operations, not necessarily PEMDAS, but we're thinking what order do I need to do things in? So it's the most complex thing first. So I got a division problem in there, right? So I'm going to do my division problem. So I'm going to do the 16 divided by 8. And then I'm just going to write everything that's left. So 14 plus 8 minus 6.
2.
16 divided by 8. Thank you. There's a 2. Must be getting close to lunch. And now your question is, do I work left or right? You know, it doesn't really matter at this point which direction I go, but since I have an addition problem first, I would work left or right on that one, because... Did I answer your question?
So you're just...
Right.
I think it made a difference in my class when because I asked for those misconceptions and also the multiple choices. You could subtract. So we just wrote it as 4 steps, grouping symbols, exponents, or division. But it's written
It's written this way, yeah.
this way.
And I'm okay with PEMDAS too, as long as they understand what that acronym means and they're not working down that acronym left to right. We don't want to teach kids things without the context behind this. That's what I'm trying to say. There's lots of little pet words that everybody uses that we use inappropriately in class. And here's the one that drives me the most nuts. I hear it almost every time I'm in a classroom and it's used incorrectly. Is the word cancel. You guys haven't had that conversation about cancel? When something cancels, what happens to it when it cancels? It's gone. It does not become a 1. When things cancel out, they're 0. When you think about canceling out, it turns to nothing. So think about that next time you say that word cancel, because I bet you 2/3 of the time you're in your classroom and you use the word cancel, you're using it in the wrong context. And we mess kids up down the road when we're saying that, so we have to think. When something turns to 0, it's canceling. If you're getting a 1, it's not canceling. It's reducing or simplifying or other words, but it's non-canceling. So there's lots of these things.
It doesn't get smaller. It's still the same value.
Reducing is probably not the best word either. Simplifying. Okay. Lunch is here. We'll finish this conversation, but talk about the things you say. One thing real quick. During lunch, your lunch conversation is around things that you say in your class that are leading kids down these rabbit holes or cul-de-sacs.
Joan just said I wasn't
And I was trying to say, but I was looking for like,
I went in the way we had before.
Oh, okay.
no, I'm just saying, I black.
Yeah.
So I kept.
Which way? This one?
This works.
Come on, Anna, it's something online.
So does like the house and the roofing? Because like I'm still like, so should we not be teaching dirty monkey spell bag, like divide, subtract, multiply, I like it. We do dad, sister, mother, brother.
To see if that smaller one is divided.
The only way I see grouping simple is like when this is a group and this is a group. Because you have like a numerator, they don't have whatever you do on one side, you're separating into
Girls are at camp right now.
Thank you so much for getting me on. Thank you.
And then we'll switch next year. Yeah, 2 or 3 years ago.
So that's what they would think. Grouping simple. Treat it as both. And what we do in the house,
Okay, no.
It imprints in their brain that you're going to and that might be a good way to show it. It could be this or it could be they're fourth graders. Well, I was sharing with him, I texted my daughter, who's going to be a freshman and was going to be in seventh grade. And I texted her, I said, first one to for cancer. With their work, it's perfect. My daughter. And this is someone that she got a Brandon cashier. And then they come out as well. And I said, try again.
You guys watch me game last night?
She's got my son's trainer.
Okay, so what happened? You made it come back.
Yes. And now it's starting
with it started.
Graduation. So does it have a lot of buy-in? Do they have a lot of buy-in? Yeah.
Well, that's what I'm saying. What's his motivation?
Let's just bury those things down.
The whole, when you multiply by 10, it's out of 0, it's 500, out 2 zeros. And then we just mentioned the whole, you don't say round up and round down. Like, please notice if something tongue to us and we spend the whole time trying to break them. Like, no, that's not how it works, because you don't take it down. Like,
right, it builds a misconception, right? So everybody get the whole thing with adding a 0 when you multiply by 10? Yeah. That doesn't always work that way, right?
Can they use the microphone so that it can pick up right here?
So the comment over here was the ones that they recognized in the article that they're guilty of is the adding a 0 when you multiply by 10. One of the things I like about this article is it tells you where that procedure dies, right? It's like, it works up until about 5th grade, and then the kids are in trouble if that's what you taught them. So I think that's interesting if you look at that. What was the other one?
The rounding up.
Rounding up and rounding down. That can create some misconceptions down the road. I always have kids that struggle with rounding up.
Isn't the misconception just from what it says?
Yeah,
because that's what I'm saying. Down, you
right.
Keep it the same.
Right. You're not rounding down. You're not taking something down. Okay.
Yeah.
Any others that you guys thought of as you were looking through the article? Yeah.
I always do, just trying to get them to remember the difference between the numerator and the denominator. And we always talk about the denominator is like this big number. That's not true at all. It's not bigger than the number on top.
It doesn't have to be, does it?
And it's a misconception for them to think that that is bigger because that's actually smaller pieces.
And you were trying to probably give them a way to remember it by thinking denominator, right?
Exactly.
And yet, in the same time, you're actually building a misconception by doing that. Good.
My daughter came up with a subtraction problem in first grade, 2 months, 2 subtract 5. And it was on her math decks. And I sat there at the kitchen table and I almost told her that she couldn't do that. And then it said, actually, you know what? And, yeah, I'm not going to explain it to you. I wrote negative paper and I said, take it to school and ask the teacher if she actually meant for you to do that.
What grade? First grade. So it probably wasn't 2 minus 3. Or was it? It was 2 subtract 5. It probably wasn't meant to be 2 minus 5. But it's interesting. A lot of times we say to kids, you can't do that. One that.
Like when you're
can't do it yet, or you haven't learned enough mathematics to be able to do that, to understand that. One thing that drives me crazy in high school is we'll say, and some of you will remember this from high school, when you have a parabola that does not hit the x-axis, we say to kids in Algebra 1, there's no solution. That is a lie. That is a lie. We tell that to kids. There's no solution. There is a solution. They're complex solutions, but they're solutions. And then when we get to Algebra 2, we teach them about complex numbers, and we say, oh, there are solutions to that. They go, wait a minute. My Algebra 1 teacher told me there are no solutions to that. And we're like, you have to backtrack all of the lies you told them and when they're freshmen. So we have to think, when you think of on a number line, how many times have you walked into a first grade classroom and it starts at 0 and there's nothing on the other side, right? And there's no negative side of the number line. And I agree, but still it leads to this misconception about the fact that there's nothing to the right on the number line. So it makes us kind of rethink some of the things we say and do with our kids, right? I'm gonna let you take the test because we have other stuff to do. Do we know what they're going to do if they finish before everybody else, or? Yeah, you have that 13 rules article, and if you have your computer open, I have another article that I put in there from Joe Bowler that's really good. So there's reading material.
All right, I lied to you, I'm back. But really quickly, I forgot to share something with you. If you have your ECM book out, Extending Children's Mathematics, and you turn to Chapter 3, that's another nice thing you can do in the next little while. Chapter 3 is all about what we talked about yesterday and today, multiple groups problems. So this is the multiplication, measurement, divisions, where we have a whole number of groups and a fraction as the size of the group. So that will help solidify some of the understanding. You're going to see some kids' strategies in there. You can't open it while you take the test, not open the test. But it goes through exactly what we went through the last couple days. What page is this? 48. So chapter 3 is all what we've been doing the last day and a half or two. And then, so that'll be a good chapter to read while what we did is kind of fresh in your minds, because it will just help. You'll be going, oh yeah, oh yeah, oh yeah. And that helps. And then if you look on page 65, just like with the equal share, the partitive division, they're going to give you some sample problems. So on page 65, 66, and 67, there's sample problems, and they're arranged again from according to difficulty level, easier numbers, and the numbers are what. So there's some sample questions and number choices there from basically easy. And then you also see that after the story problems are some equations that kids can begin to problem solve around. So 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2 equals m. Have that, they can problem solve around equations now. Simple equations with the kinds of ideas that are coming out in their stories. But you still want to ask them, how did you think about that? How did you solve it? Is there another way? Because if you look at, let's look at one of them. How about C? And I really encourage you to say groups of. So somebody read C with the groups of term. 67. Four groups of 1/4 plus 3 groups of 1/4 equals box. So if we put an M there, which I do with first graders and they're not have a problem, you just say, what should M be to make this true? And M can be a lot of different things. So don't say what number can M be, because now you're limiting it. Just what can M be? So what's one thing M can be if I say 4 groups of 1/4 plus 3 groups of 1/4 equals M? What can M be? 7 groups of 1/4. So they're learning that M can be an expression. It doesn't have to be a single number. In algebra, it's going to be an expression often. What else can M be? 7/4. What else can it be? And then you'd ask them, how do you know? You know, those kinds of things. 1 and 3/4, where'd that come from? So just like story problems, equations, these equations are set up as well to not only build off of what kids are talking about in these problems, but they're going to have multiple solutions if we do that. Is there a true-false one in there? Look at, all of these are open, but you can make it a true-false. So look at L, for example. You could say, put up 7 groups of 7/8 equals, what would go in there? Ooh, that's a cool one. What would box be? 7 groups of 7/8 equals what minus 1 group of 7/8? Yeah. So see how the groups of really supports your thinking about it? The times doesn't do it. But if you say 7 groups of 7/8 is the same as what minus 1 group of 7/8? Oh, 8 groups. So those are sort of some samples that you can either put the amount in there and ask them if it's true or false, or ask them what should it be to make it true. And they're fun to play around with, coming up with those. If you turn a little further, that's the right one. I was farther, further. You're going to see after page 68 continues with a couple of those, some more equations. And there's some that the kids can start writing story problems, so 6th and 5th grade especially. There's some nice equations that you can have them go home and write a story problem too. Let's try one of them. Somebody, how about C? What would a story problem be for C? 3 divided by 1/4. Remember what those quantities mean.
See on the back.
You have 3 yards of fabric.
You have 3 yards of fabric, and for whatever you're making, you have to cut them into 1/4 yards chunks. How many chunks of fabric can you get out of that 3 yards?
So it's just asking how many 1/4 are in 3.
You have 3 yards of ribbon, and you need a 4th of a yard for every present. How many presents came around? So they can begin to create their own story problems out of the equations. Then on page 69, 70, and 71, and is it 72? No, 71. There's the instructional guidelines for the multiplication and measurement division by grade level. And again, if you're a 5th or 6th grade teacher and you look on page 71 and say, hey, it says my kids should be able to think about these kinds of ideas, what's it assuming? They've come from, so you might look back a grade or 2 to see what experiences you might want to start with before. The good thing is that even though you have to go back a little bit often with 4th, 5th, 6th, they have more complex brains, believe it or not, they really do. And they will move much faster. So the speed that a 2nd grader is going to go through these ideas is not the same speed of 5th grader or 6th grader. So once they get the basics, they tend to run much quicker with it. So don't say, oh man, I don't have to go all the way back to 2nd grade. It's okay. You won't stay there very long. They just will. They're just able to think about it more quickly. We are too, otherwise we couldn't have done this in 5 days, right? So that's this as a resource for you. So your assessment is in 2 parts. It's identical assessment that you took on Monday. So the first part, if you recall, is a single sheet, but it's double-sided. And it's asking you to solve each problem using multiple correct strategies. Use strategies that are similar to how a child would solve it. So 6 kids sharing 5 apples. And on the bag, each bag of peanuts weighs 2/3 of a pound. If I have 15 bags, how many pounds of peanuts do I have? So hopefully you'll have fun now thinking about ways that kids might solve it, and I'm looking forward to seeing how they compare to Monday, because I looked through Mondays, and I'm excited to see what Okay, I did not mean that in a negative way. I just, if we haven't learned anything. What's your red?
She said that table has lots of
Well, I mean, we should, right? We should have given you an assessment. If you didn't show growth, then you've wasted a lot of time here this week. So that's what I meant. So that'll be exciting. So this one you'll do first. We can't show you the second one because it could be supportive to you. And so you'll do the front and back of this one, and then just come and set it on the back table, and I'll leave the second one back there. The second one is you're looking at some student work, and you're asked to just choose 3 of the pieces and talk a little bit about describe the strategy. You can bullet it. You don't have to write in, narrative. Just bullet if you like. I'm a bullet person. I think it bullets. And then you're going to describe 3 of the strategies right on the child's paper itself. and then you're going to choose 2 of the kids and write a word problem that you think you would make sense to use based on what you now know about the child. And just write the actual story problem. Some of you didn't write a story problem before, so write it. Jack had, so make it a story. So any questions about these? Not open book. Don't. I'm going to watch you.
Can we use our notes?
You can do it. So the double-sided, single double-sided page is coming around, and then I'll leave this one on the back table, and you can just split them. Not open notes, sorry.
We did as a team. Much better. My brains are collaborating. I barely touched it.
Visualize.
Wow. Talk about lack of trust.
What's the other word?
Really know it's important.
My dad.
You only get to 3 in one book.
Sorry, I apologize. I thought you actually shot a test.
But that's not the question. How many chairs?
It needs to be individual. Just checking. You can draw pictures though. Lots and lots of pictures are fine.
goes to the 20 stipends, where you're a third of that.
So, you finished the test. I just asked for 10 minutes because you could see the schedule is changed a little bit today. I don't know if you are aware, but we heard that unfortunately some people need to leave. There is a funeral today. So all the groups had the test earlier than originally we scheduled, so that for the rest of the time it will be mostly lesson study preparation with CAR. So we don't have today separate mathematical modeling session like we used to do. But I also would like to thank you all. I am not abandoning you, but on Sunday I am leaving to Hungary for 6 weeks. I am on sabbatical leave, and I will go to 2 conferences and stuff like that. So I will be hopefully not flying by that time already, but it's like 26 hours to get back, so almost till the 20th I will be traveling. So I will skip the 20th, but I will work, Carl will do the majority of the lesson studies, but I will work in October and November with the group 13 and 14, and in January also, and my teaching schedule for the spring semester is Tuesday, Thursday, so we worked it out with Carl that I will have a chance to see 15 and 18 working too, and he will take care of the second teaching at the second teaching time, substituting each other for one time. So I am really looking forward to seeing all of you in action, because that's the real interesting part. What are you doing? What is the impact of this thing for the students in your instruction? And I owe you this problem yet, and I was very, very glad to hear from Jennifer that some of you were asking for it. And before we get to this problem, it's kind of interestingly emotional to me too. Any of you were watching Hugh Hauser's memorial thing yesterday on PBS? Anyway, he happened to be, I liked his show very much, and it was pretty neat at the end when he donated all of his money to a college, and he was singing together How Beautiful is California with a bunch of college students and things like that. So that reminded me that it was a very nice experience for me working here too. And in the same time I felt like a grandma and as a child. And I wanted to share this with you. Like, Carl happened to be a student when I was already teaching here, and he didn't learn from me much in the methods class, because that was a very weird thing. There were 3 students and I was new, and I have never taught a class for 3 students, so it was a very weird setting. But I was very happy to see that he grew and learned a lot about methods anyway. And for example, Jeff was also master student working on his final project. I was taking the responsibility for Raji, who was on sabbatical on that time, and he also did pretty much on his own the work, but it was fun consulting with him and discussing neat ideas. And I saw him as a student teacher too. I remember when he was in Clovis doing his student teaching, and I still like some of his ideas, like one of the, I mean, I like all of his ideas, but I'm using some of his ideas when I teach, for example, statistics. So the game he was playing there with distributing wages and so on, and then who wins, whatever. It was a fun thing. So working, seeing that, hey, these people made it. It made me like a very proud grandma. And I also felt like a happy grandma because I felt that you had semi-parents who took care of things, and I could just walk and have fun with you, like grandmas used to do. like they fed you, there were all kinds of things seamlessly working around, and we could have fun, playing and then walking back from the playground, and I could leave them in good hands and such kind of things. But I also felt like a kid in many sense, because it was great to see so many people smiling, and that made me smile a lot this week too, because it was like, so what is the next challenge? What can we do next together? Let's play this game. Instead of, oh, why do I have to be here? When will it be time to go? Let me go out of here kind of experience. So it was really fun. Thank you very much.
Thank you.
So here is a problem. I know some of you succeeded already, but we never talked about it. And I wanted to check your perseverance, whether meanwhile more people come up with a solution too. So who believes has a solution?
It's a yin and yang.
Okay. We have two. Maybe most of you can go simultaneously. Where is a pen for that? Yeah. So you can draw on that, and I prepared already here. So let's see what did they come up with. Yeah, and then I will ask, I mean, if it's the same, then it's okay. If not, I want to see your explanation too. So your task was to cut it into two congruent parts.
Well, I thought it was draw a line and make a congruent figure.
Oh.
No,
it was cut it into
Good job.
As a matter of fact, I am really happy you drew that, because I think to explain how to get this solution, this picture is telling more the story. Some of you really refer to it like a yin and yang figure, right? If you think, how do you make that figure? This picture shows it, and that helped me to draw it too. This is like a half circle, a semicircle, right? And if you think about it, to make that fancy curve, it is like you draw into this big circle two small circles. Those small circles would have half as big diameter as the original, right? That's the way it is done. So how on earth did he make that cup? I believe what he's saying, and that's the bad blue pen for that. He claims this piece is exactly congruent to this piece. You can see it has kind of like, both of them has a bulky part and a little like tail, kind of like just going into a vertex. So it looks more or less good. But is it really exactly will be congruent to pieces? Well, do you want to explain? Why do you think so?
And again, my drawing is not the greatest, but this cut right here is, that she said it'd be a circle, so I took this same size cut, it's supposed to be, and put it also right here. I guess just take a step back. This size cut is the same as this size cut right here. All right, we'll agree on that. And so if this size cut is the same as this one, I took another one of these and put it right here. So these are going to be the same size. We know that if this is the same size, this will also be the same as this part right here. And so you just kind of take it, and I broke it up into 4 parts so you can hopefully see, or the two, but how they kind of follow each other.
It's beautiful. I just wanted to suggest, why did I think it fits so beautifully to this workshop? You saw a bunch of times kids getting the quarter of a circle is very easy. Now if you think about it, for example, cutting in half a circle is even easier, right? What I'm saying, this yin and yang thing, is cutting the circle exactly into two pieces, right? Whatever is missing here is added back here. So this is exactly a representation of a half, of a semicircle. So now if you think about it, this is the relationship between the one half, and yin and yang and straight. If you generalize it to the quarter, these are now all congruent pieces, right? Just you made it a little curvy. And that's exactly what he was doing there. Those two pieces are two quarters. Two of these four nice curvy quarter representations. So they must be exactly the same. I love symmetry also. If you think about it, I was first thinking about it like a fan, right? You could make a fan like this. It is just always, you rotated it by 90 degrees. They have still the same things. But it was one of the favorite problems of mine. I told you that professor who posted it was like 80-some years old, still teaching in Hungary. And he always messed up rotations like I goes from I to I and things like that, what he wrote on the board in big summations and all kinds of strange things, but he was full of fantastic ideas. There was a lot to learn from him. And this is a problem I have seen 6th graders solving it beautifully. And it's as challenging for somebody with a PhD as for that 6th grader. So it's the issue that we can learn a lot from kids too. So I really hope you will take it to your heart what you were thinking now on student thinking. I really hope that you will take seriously. It's not just to try to understand what the heck is in their mind, but as we expect them to understand what is in our mind and what we try to tell them, learning is always two ways. We can learn a lot from our students. And that's the final thing for my circle. I wanted to thank Carl and Jeff. They paid me back for trying to teach them. I learned a lot from them, maybe more than they learned from me. And I think it was really a pleasure to work with Jennifer and John. They were new to me, but it's like extending the family. And you are also, hopefully, come back and teach me a lot of nice things you learn from your students too. Thank you very much.
I'd forgotten, Agnes, how many years ago that was that I was your student in this class. That was a long time ago. I have to put my glasses on to be able to see where the on-off switch is. There it is. Why don't I just hand it off to somebody else? I was having a conversation with a teacher right before I gave it to Agnes. And I wanted to just one more thing about this whole, what do we say to kids that maybe is leading to misconceptions down the road. On Thursday next week, one of the things we're going to do is we're going to push you by schools. And so that your kindergarten teachers and your first grade teachers and your second grade teachers and your third grade teachers and you guys will all have a conversation around that article. So make sure you take it home with you and read it again Wednesday night before you come in on Thursday, just so it's fresh in your mind. Because we want to have that conversation across all the grade levels about what we say that's maybe leading to misconceptions. So one thing that's interesting about this grade level, 4th grade through 6th grade, is you guys are depending upon stuff that was built by teachers before you. One of the things that's huge for you guys to get the work done you need with your kids is that kids come into you understanding place value. Agreed?
Yes.
And I have to tell a funny story. As a high school teacher for 11 years, kids would come to me and they could not multiply or add or subtract sign numbers to save their lives. They really struggled with -2 plus +6 or -3 times -1, right? I mean, their brains would melt. And so as a high school teacher with only high school experience, my first thought was those middle school teachers must be morons.
Hey.
That's where my brain went, was why can't they get this done? They're screwing these kids up for me. And then I went to work at the county office, and I actually worked a lot with middle school teachers and with teachers at your grade level, and I realized, okay, it's not you. It's not what you guys are doing so much as what we as a profession are doing. And so what I want to talk about really quick is this idea of place value, because place value is really drilled. Most of you would complain, my kids don't understand place value. You go back and watch what's happening in second grade. Some of you have taught second grade and now are teaching 4th or 5th or 6th grade. You know you did a good job with place value. Dang it, why are they screwed up? My suggestion to you is the way that we teach some of the standard algorithms are messing up our kids' perception of place value. That when they're in 2nd and 3rd grade, they do everything according to place value until it's just drilled and drilled and drilled, they get it. And then they get a little further up and we start teaching these algorithms like the standard multiplication and division algorithms that completely ignore place value. Agreed? So when you divide 8 into 286, what's the first thing you say to kids? You say you take your 8 and divide it into 2. Well, but that's not a 2, is it?
No, 200.
That's actually 200, isn't it? See the problem? We're calling this a 2. And we're calling this an 8. See where our kids are getting screwed up as they move through the system?
So it should be 280.
Well, here's another alternative to thinking about division, long division like this. Instead of, and it's still part of the standard algorithm, but it preserves place value. We say that multiplication is repeated addition. Then wouldn't division be repeated subtraction? You guys ever seen this before? 800 is too big, right? So 100 times 8 would be 800. That's too big. But I can take some 80s out of there, right? How many 80s fit into there? Think about, just multiply 8 times 2, 8 times 3, get 3, right? So if I went 30 times 8, what would I get?
40.
It's pretty close, right? So what we do with repeated subtraction is you just keep track of your subtraction off to the side, right? So if I do 30 times that, I get 240. Everybody okay with that? And I get, what, 46? And then 8 goes into 46 5 times. Gives me 5 times, it gives me 40. And then I'm not sure what grade level you're at to deal with remainders, whether you put it as a remainder or as a fraction, whatever you do. But your answer is 35, and your remainder, however you want to express it. But we're repeating the subtraction, we're preserving place value. My place value is preserved. 30 times is that, 5 times is that. I'm not thinking of that as a 2 or that as an 8. Does that make sense? Same thing with your multiplication algorithms. We say 5 times 5, but then we say 5 times. You see where the confusion's coming in? That's not a 2. Never was. It's in the tens place. It's a 20. So instead of writing it like this, write it like this. And look, how many multiplications do I have to do here? 4, right? If I stack them like this, how many multiplications do I have to do? 4. There is no extra work. None. It's the exact same multiplications, but it preserves place value. I'm thinking of 25 as 20 and 5, and 15 as 10 and 5, and if I do my multiplications, 5 times 5, 5 times 20, 10 times 5, 10 times 20, stack them all down here, all the zeros are there instead of saying, oh, just leave a space, or put a happy face there, whatever you say. I mean, I see some crazy stuff, right? But this is a place value way of thinking about it. So just little things like that, as you know, I got tired of complaining and I thought, well, how do we fix it, right? So these are just some simple fixes to this idea that they get past you and they're going to forget place value because of the way we teach some of these standard algorithms.
Now I will say the multiplication, like the book now addresses that.
Yeah.
Like, we address that now. I would, don't get mad at me, but I would then take them to the side.
Get out!
But I would then have them set up the problem 20 times 5, which I know they should be able to look across and they shouldn't need to line it up like this.
What I would do is I would do this with them, and then I would do this with them and show them where are the zeros and what's actually happening. Yeah.
Isn't this how the Japanese teach it?
Well,
this is like Kuman.
Actually, it's everywhere except for the United States. I don't know if you guys realize this, but this standard algorithm multiplication is only found here.
But even the division.
Only here.
Even the division.
Yeah.
The division I see my kids having a lot harder or the time grasping onto. The multiplication's not so hard, but just because of the way they've been taught up to this point. To get them to look at 286, like we just need to chunk the number down. Does anyone, get anyone think of a way that we can chunk
it by and keep place of our, or keep track of our place value. This standard algorithm, you know where it comes from? It's a holdout from our old ledger books that we used to keep books in, where we have these rows and columns that we used to do these ledger books that finance people used to keep. This is a throwback to that. And we are the only country that uses this standard algorithm. Nobody else uses it, and we're just like tied to it for some reason, and I don't know why we are, but there's other ways to see the multiplication that makes more sense with the place value. I really think that by the time they get out of 3rd grade, they got place value down, and then we feed it out of them over the next 3 years, and then they're fine. Okay, have your computers up, and hopefully you've logged on through your Clovis Unified Google account. Clovis Unified Google account. And this is my Google account. Those are all my folders. And notice Jeff invited me, so now Camp Teacher is in my Google account. And I'm just going to click on it, open it up. And when you go to that account, that's what you're going to see. 3 folders. There's the intensive days folder, and then there's the report working. Wow. Rebooting. Oh, no. I'll give you a second. And if you just want to watch, fine, that's okay. There's a couple of things we have to get done today, and I'm going to show you some stuff that I've stuck on in this folder, and I'm going to need some emails from you, and so I'm going to show them my email address in a second. So if your email is up and running, you can just get it done. Before we go any further, it just dawned on me right now. I need you back in your groups by your lesson study groups. So take a second, pack and stack, and move to your lesson study groups, okay? 5 minutes. This is a great time for a break. How's that? 10 minutes to get into your lesson study groups and take a break, go potty, get a Diet Coke. Get a donut. There's lots of donuts. You need sugar for the afternoon. You need sugar. You need energy, starch. And it's Friday. Calories don't count on Fridays. They don't.
this is when you go to favorite things. Only just Magic Friday. I like Magic Friday.
Magic Friday. There's 6 tables, 6 groups. We should be able to work this out. You guys already in your group? And you're saying, I'm staying, make other people better.
Okay, we're coming. I think. So, right?
Sure.
We are.
No, we have 1, 2, 3.
Give me a minute.
I don't know where anybody's going, but I'm going to go.
How do you think
We're here.
Amy, are you still?
I might as well go back. It's fine. So they'll just come over here.
It just takes, I need someone to move my chair.
Where are you moving at?
Oh, way over here. Sorry. Way over
Type in like on your computer. Are we leaving you on or not? Yes, sir.
I'm just trying to shift my stuff. Do we have a plug though?
Okay, are you guys going to church?
So we are okay. I can't. No, I'm over there because there were 3 right over there. I was wondering
That boy, that huge man, was in my circuit. Why? I know. Is that like
I need a band.
I'm just moving my things out of here.
Are we all over here?
Nobody wants to do that.
Yours or mine?
2:30.
Okay.
No, it says, rush up back there. Take your computer to that guy.
I know.
No.
No, not now.
We get booted. Help me now.
No help for you.
My kids can do it. I don't want to do it, right? Yeah. I know. Yeah, me too. I have all this junk. Yeah.
So where do I go?
That's me. I'll move. I know. I'm moving. I don't have any power. I think it's the same.
So, once you're in here, as long as one.
I was very excited.
Don't make me pick up the microphone. Okay. Because I don't like it. The 3 folders that you see across the top, the first one says cohort working folders. That's where you're going to stick your stuff for your lesson study group. If I double click on that, you'll see there are groups that have already put their stuff up. See that? There are, and you don't have to put the A or the B on if you don't want to. It's not necessary, but you can if you want. But the A and the B, the letters are just for your, the only reason they use letters is when we go and do those CGI days, you're going to go by letter to the CGI day. You're looking at me confused.
We're going to separate in certain respects.
So your lesson study group is just the number. The letter is going to designate which group you're going to go on the CGI embedded days. Those are the days when you're going to be with the CGI people watching student thinking, and we'll try and you'll actually be watching kids and they'll be interviewing kids. So there'll be a bunch of you, it's like only 5, there'll be like 25 of you on a group on those days. So, how to load a folder. I'm going to give you a really quick overview of that. Here's the easiest way, and some of you are probably going, oh, there's an easier way, and I learn stuff all the time. So if you're on your desktop, and you create a folder, creating a folder, you just right-click, hit New, and then Folder. Click on it, you can create a new folder. Name it your group number, right? And then stick all your stuff in there that you want. And right now, there's probably absolutely nothing in there. That's okay. If you've already started to gather some stuff and you want to put it in there, great. But it'd be nice if you at least start with your folder. Once you have your folder, in here, you're going to go under where it says New, and you see the third thing down, it says Folder Upload. You click on that Folder Upload, and then you go to Desktop, and then you hit that folder, and it will upload that folder right into that file. It's that fast.
Okay, I'm well over 30 and grew up with the rotary phone. Can you say this all over again?
To upload a folder.
Sorry.
Here we go.
I get that because I am
no
now on I'm now on the 3-folder thing. I got to that part.
So, once you have a folder made, get it named.
In the drive. The folder in the drive, right? The new folder inside the drive?
No, you're on your desktop.
Anywhere, okay.
Yeah.
I didn't hear the
In My Documents, on your desktop, wherever you want to be, you have a folder made. And you only should do one per group, right? So whoever's the person is going to be doing the folder. Okay?
Well, nobody else is doing it.
So that was a good point. Everybody, eyes up here. Please don't have everybody at your table load a folder. One person from your table load a folder for your group. I should see 6 folders, say group 13. Okay. Once you have your folder in and named, then you go back to your Google account, your Google Drive, and I'm going to back up a page. This is the home page. You go into the working cohort folders, and then once you're in that folder, you hit New, and then you hit Folder Upload, and then it's going to ask you where do you want to upload the folder from. So I would go to my desktop, and then I would go down to that new one that I just had, that new folder. I would click on it, and it now, see how it's loaded, it says new folder, and then I would just say OK, and away we go. I'm not going to do it because I don't want a blank folder that says new folder. Yeah, I can definitely.
Yes.
Everybody okay with how to load a folder? Okay. I'm going to back up. Under the intensive days folder. Cohort 14B, where are you? I did it wrong last week, sorry. That's okay.
I'm kidding. I'm deleting it.
I think you can just grab it and move it in.
Thank you.
If you go under intensive days, I should have, look at that, you made it share. If you go into intensive days are these days that we all meet together. In that, people deleting other things too. Where did the other one go? Who's deleting folders?
Flash of
Jeff, I'm not sure we giving them access to be able to do that. Things are disappearing.
If we can't allow them to,
we're going to have all of our stuff up here. And you're going to delete it on purpose.
the problem is, guys, here's the thing that you have to make sure you know about deleting and all of that stuff and moving. You have to be careful because whoever creates it is the owner of that folder and it's shared with everybody else. And sometimes if you go in there and move Google, there's some glitches sometimes. Here's something that happened with the 7th grade curriculum design team. Unit 6 was all done. Curriculum guide was all done. All of our tests were all done. All of our quizzes were all done. They were all loaded into Google Docs. And then one of them said, you know what, there's an issue with something's not, can you fix it? So what I wanted to do is I wanted to not have them in there changing things while I was looking over it. So I said, well, I'll just take that stuff and move it to my drive out of the shared folder so I look over it so they're not changing it while I'm trying to edit it. I wasn't the owner of those files because I didn't upload them, and I moved something out of the shared file to my, as if I was trying to steal something. So I don't know if it's a security thing, but what Google did is they denied access to everybody to all of those files, including myself, including the owner, everybody just deleted them. Nobody in the district, not even the person who created it, had access to them. It just disappeared. I had to do like 3 days of research to find out now it's some orphan file out in cyberspace. And the only person who was able to find them was the person who created them. So now I had to, okay guys, who created all those? And they had to search for those files one by one to find them out in cyberspace. So you've got to make sure that you're not fiddling around with other people's files because weird things can happen. But here's the problem. The reason why you have access to delete is because you either have access to edit or you don't. And you can't even create if you don't have access to edit, which means you would have had to send me all your stuff and I'd have to upload it all. And we don't want to do that. We want you to be the owner of your folder. So just be careful. You might want to have a backup copy of everything that you're doing sitting on your computer. That's just where you go to share it.
So Jeff, just so you know, somebody accidentally deleted the whole folder. Is it? Oh, it just got moved into this folder? Move it back out.
Right click on it.
Somebody moved it. Yeah, where'd they go? He's fixing it.
And your hands keep your And notice the warning, others will no longer be out of that folder. But as long as you stay within the teacher folder, you can probably find it. But just be careful, especially those of you with touch screens. That's all it takes. You're pointing, oh no, move that, and you've just selected it. So just be careful.
Okay, so in the intensive days folder, if everybody would go there. Absolutely.
Here's the one thing that you do need to know. If for some reason, you guys, okay, and this is why we love Google. If for some reason you accidentally delete something and you're like, oh, I just deleted cohort 18's entire file. You call me, okay, or you email me and you said, I accidentally deleted cohort 18's file around 10:45. Because you see this?
You go back.
This is a history of second-by-second activity in here, and I can go to any moment and reinstate that file from that moment. So I can go back and I can, oh, it was deleted right there. Let me go back 5 more seconds. There it is. Put it back in. So you can recover it all. So just know that. Well, you can too, but I know how to do it without explaining it to someone. And it'll be faster for me to do it than try to explain to someone to do it. But, so it's not the end of the world if you delete something. You can usually find it unless you do what I did and make it not available anymore. So that's why we like it, because there's a history, you can always find it.
Under intensive days, there's the 3 different groups that we're all broken into. If you want to see what the 2nd and 3rd grade group have done, you can go into their group and see if they have added nothing to theirs. I feel so much better now about myself. So in our group, I have added a new folder. So all of these are just the schedule for the week. Right up here it says PowerPoints and articles. If I open that, there's 3 PowerPoints. So there's the 3 PowerPoints that I used with you guys during the week are there. There's the fractions and dieting. There's the first day PowerPoint that I did. I can't remember what it was about now. And then there's one on lesson study, the PowerPoint that I used for lesson study. There's also the 13 rules article, PDF for you, and the article that's below that is from UQ, and we're going to talk extensively about that article on next Thursday. But if you want to read ahead and see what we're going to talk about, you're welcome to, because I already loaded it in your page. Okay? I have to go through the title and figure out which article. Unlocking Children's Math Potential. It's a Joe Bowler article. Here's what I want to go to really quick. Where's my facilitators in each group? Raise your hand, facilitators. 1, 2, 3. This table back here, raise your hand, facilitator. Facilitator. There you go. Good. I need an email today, and I would like you to email your entire group and me and Jennifer. And in the subject line, all I want you to do is put the number of your group and then put email addresses. And then once you send that email to me with everybody else's email too, I will have everybody's email. Does that make sense? That's your first task, is use my email address, and you have Jennifer's email address. You guys did already. You're the one group that's done. The one that we I got it. So pass the computer around, get everybody's email address, and then that facilitates the body of the email.
Do you want it in the body of the email, or do you want it? Can it be up in the send?
It can be up in the send. Okay. I can grab them out of the send just as easily as grab them out of the body.
Group email that we set up. Right?
Yep. You can even put you don't even have to put anything in the actual email. All I need is the email address.
Gotcha. Okay, so you can send them an email.
And if you would put, just so I can keep track, if you would put if you send it to me, and then have everybody else's email, and then CC Jennifer so that she's not with the rest of them, because I'm going to cut and paste all those email addresses, and if I keep doing that, I'm going to get Jennifer's email address like 8 times. Trapped in different folders. So that will make my life so much easier if you guys all email me those. Then I just highlight them all, stick them in a folder, and I'm good.
Yeah.
You can delete the subject line, you can delete all the content. It's just the
That was a good idea. What group number are you guys? Group 15 said, we're actually going to put together a contact list in our folder that's going to have our email addresses and our school and our grade level and maybe a phone number. That'd be great too. Put together some kind of contact list for me. That'd be awesome.
Carl. She's already done all of that.
Oh.
As far as having every cohort with all their emails and everything.
Jennifer's already done this?
So she can send you an email with their emails all in it.
I can't hear it.
She can send you an email
By cohort.
by cohort, so that you have, unless you want them.
Practice for them.
Okay,
that was the first task. Next task, I need you to, I'm going to close this out. Everybody has my email address, right? Easy. My first initial, last name, at fcb.org. Oh, I did not want to do that. Yeah.
You make that? You make that?
You know, we'll talk on Thursday, but I think I will probably just send out a little reminder saying, hey, remember we have a meeting on such and such day, and then you send it out to everybody else. I just want to communicate with you, so. Okay, here's the last thing I want to show you in that folder that I put in there. Is I put a list of URLs, and I wanted to show you around where these web addresses. So I'm going to blow this up a little bit, if I can. Maybe I can. I'm going to shrink that down, and I have it.
I have to add him to that group.
It's too small for me. I need to make it bigger. 11 font. Who was thinking 11 font? What was that about?
Again, they're under 30, Carl.
What's that?
They're under 30. They don't have to be over 30.
I was thinking about myself. Why did I leave it in 11 font? I typed it and I left it in 11 font.
You're young.
Okay. The websites that I want to spend a few minutes going through for you for resources, I'm going to let you play and look in them. But what I'm going to do is describe what's in each of them. So the very first one is called Illustrative Mathematics. How many of you have heard of Illustrative Mathematics? Raise your hand. What a sad thought that only one or two of you. Illustrative Mathematics. How many of you know about the website called Illustrative Mathematics? Wow. Okay. The people who wrote the standards, the Common Core standards, knew that for some people, reading a standard is not enough. They need illustrations of what that standard should look like, called problems or tasks. So they've written a whole series of math tasks on every single standard. So you go to your grade level, you go on the standard you want, and there'll be a whole list of tasks that they've written. Wonderfully done. Not all the tasks are great, but a lot of them are very good. You have to pick and choose. Other people can submit tasks to be put on that website, so I'm not going to vouch for all of them. How many of you have heard of Mars tasks? You guys have heard of that term, Mars tasks? Mars stands for Math Assessment Resource Service. It's out of England. Their tasks that they have been used with students for probably 40 or 50 years. They've all been alpha and beta tested. Beta tested means that they have data from kids on how well kids do on them with student examples and student work. And all of their tasks have been correlated to the Common Core and stuck on Inside Mathematics. So the next one down, there's great resources in there. So I would always go, those are my two first places. If I have a topic, if somebody says, you're going to teach something on 6th grade proportions, those are my first two websites I go and check. I go to Illustrative Mathematics and Inside Mathematics. Those are the first two looks I do. The next one down is Dan Myers. Dan Myers is probably, there's been two people that have had a huge influence on me educationally in the last 3 or 4 years. Joe Bowler and Dan Myers. Dan was a high school math teacher, and in 2010 he got invited to do something called a TED Talk. You guys heard of TED Talks? The reason why he's very technologically savvy, and he started a blog. And his blog is amazing. And that's just the web address to his blog. His blog made him famous enough that they asked him to do a TED Talk. His TED Talk went viral, and I must have got it sent to me 100 times within the first couple of weeks that it was out. But it's a great TED Talk. It's about the fact that publishers' textbooks are actually teaching kids all the wrong things about mathematics. That we're not teaching kids how to problem solve, we're not teaching kids how to think. Textbooks take all of that away for kids.
There was a guy with red sweater and glasses.
That would not be Dan Meyer.
That was
Dan Meyer's about 6'6" and he looks like a beanpole. Wolfram, yeah, that's Wolfram. Conrad Wolfram. Dan Myers wrote a bunch of math problems and he calls them 3-act math. The reason why he calls them 3-act math is he says any really good math lesson should be in 3 acts. The first act is where you get kids curious about what you're going to learn that day. You pique their interest. You give them, it could just be a picture, it could be a little video clip or whatever, something to make them curious about the mathematics. And he likens it to like a movie. In the opening scene of Jaws, when the girl's running out on the beach, you know, she goes to go skinny dipping, right? That was the opening scene. That's got you pulled into the movie, right? Because she's out there swimming and you hear that da-dum, da-dum, right? That whole scene, that opening scene was the hook that drug you in, right? He says, Act 1 of a math lesson should be very similar. We should pull the kids in and make them want to learn what we want to teach them that day. Act 2 is when you feed them enough information to find an answer. In Jaws, it was them getting on the boat and going out in the ocean looking for the shark. That's Act 2. That's like 80% of the lesson. That's where the kids are interacting with the math, they're getting their hands dirty, they're trying to solve something. And Act 3 is just a conclusion. You let them compare their solutions, you let them compare each other's solutions, come up with an answer, see whether they're right or not. In Jaws, it was when the shark blows up, right? That's Act 3. It's just kind of the culmination piece. Should be the very end. So Act 1 and Act 3 are very short. Act 2 is the big chunk, right? Says a good lesson is in that. He's got a whole series of probably 100, 150 problems, all set up in Act 1, Act 2, Act 3 in a spreadsheet. So that just takes you to his blog. On the right-hand side of his blog, it'll say 3-act math. Click on that and you're in. All of these are free. After that, there's been this whole movement towards open middle mathematics where you make a problem so that kids have multiple ways to look at the problem. That spawned a website. A guy from California, down in Southern California, his last name is Kaplinsky, created this website called openmiddle.com. About 20% of the stuff on that website is very good. The other 80% I'm not crazy about. But, right, 20% of it's good. And it's free. Another person that had a huge influence on me in the last few years is a lady named Jo Boaler. She's out of Stanford. Her website's called UCubed. Tons of tasks and cool stuff on that website too. Sorted by grade level and by standard. And then the last one is our county office, Fresno County Office of Education, 4 years ago was asked to create a bank of resources that people could access to help them implement Common Core. So that's the link to our Fresno County Office of Education Common Core website and all the resources that we've compiled. Okay, so that's what I put on that sheet. If you go in to this last website, it'll take you to, you'll see a place where it says links to good websites. There are 2 state websites that you'll see, Georgia and New York. You guys remember when we first adopted Common Core? The reason why we adopted Common Core so quickly is we were trying to get a grant from the federal government called Race to the Top. Not Race to the Top. That wasn't what it was called. Yeah, it was. Called Race to the Top. Like $15 billion that they hung out there for states to try to qualify for these grants, right? California never got a single one of them. We tried 3 years in a row. Got turned down each time. Some of the states that got those grants wrote curriculum with that money. The string with that grant was, you're going to take all this money and you're going to write curriculum. You have to make it public. Taking federal money, right? So we have links to Georgia's website and New York's website that if you click on those links, it'll take you right into their curriculum that they wrote, that they use that money, those millions and millions of dollars they took. They wrote curriculum. You now have access to all of that curriculum because it's free, it's online, they had to. So look for those links because you can steal, you don't have to use their curriculum, but you can steal good problems out of their curriculum.
That's what Eureka Math is.
Eureka Math is New York's curriculum. Okay? So if you look at our website, that'll take you, we found back doors that makes it a little easier to get in. So our link takes you right into where the curriculum is. So I want you to go looking around in those websites. And then if you're done with all that in the next 15, 20 minutes, if you'll just make sure that you got kind of a good idea of what topic you want to teach your lesson on. Because when you go on Thursday, when you go out, it'll be a month before we see each other. Everybody's going to want to be gathering resources for that topic. I want you to get a pretty good solid idea what that topic's going to be by the end of the day. So I'm going to shut up and let you just talk in your groups for a while. So you already have been
we had tried to do it for the process. So I think we have these three things we're going to do. Purpose areas, content area, We're trying to move us forward so we can. So it has to start going with each topic.
I know, she's already got her pressure account. The pink cursor is there, like when you go around, you can type in. Well, any of the times that you call meetings out of the classroom, I just okay, not Monday. Yeah, any of the other times that we're Tuesday, anytime from 1 to 4? Yeah, that's fine. What we're going to do in computer lab, but I mean, except for the day that she's instructing, because I want Friday. I'm going to request that I work on what she did. Yeah.
No, I don't
we're working on an LR.
do anything. CCT, so you should say.
All of us need to respond to the text in order.
Monday.
Okay, so I can tell her what she asked for. Just see where it says I can usually
continuing education. Oh, wow.
Oh, wait.
I wanted to see what you had
There's certain views that will show you all your edits.
I requested
planners.
You put one on every day. Look at this little poster they have on.
I did something.
You gotta get me dropped. Where did you find this? You can have all mine.
We had like a couple extra. No, actually, I only had 32.
Standard. You have 5 extra. Oh, you're in there, Brad. You need to come grade 6. Like, do you have a complete class set now? I just gave you that. All year was for literature. I had to check it out. But you know what? Nowadays, they're shared on sites instead of, I'm waiting for them to say, and I'm waiting they're in order to scan. I only have 12. I have a that I post every year. You would have had, did you have about 5?
Yeah, I have a something that 612. Number 56.
What are you doing?
You say read? I just, but that's what I'm saying. If you have some sort of external that you're using, you can just put it on your hard drive. That's what I have. I just have to put it on my hard drive. The literature book. So here's the whole literature book right here.
Yeah, whatever the elementary
Here's the whole book
I didn't see any place for a quick way to see this, which made me think she was
She cannot know if they got it or they did it. Yeah. And if they need to extend, there were times where I'm like, and we felt good, and there were times for the next time, I scratched that lesson.
And they do it all day.
We don't know our overall.
You just took me away.
back in the 90s, we did it.
I have it written down. If you get invited to do a test,
a chapter of history, and I'll do a chapter of science.
Why is it
After lunch, you're able to do
oh, yeah, I just do want to, like, say, like, I'm doing what are we looking for inside?
You have to sign only do it Friday.
We signed up. I got my confirmation email. I need well, actually, I teach on Fridays. I don't teach on no, history of science.
I can actually Monday by Thursday. Oh my God.
I just like they scan and put them away.
Have you gone in?
What new science was
Be careful, you have a problem with eliminating.
Oh, yeah.
They did that to me, they wiped all
What
You don't know what you're doing to me. You don't understand.
There's just one CD. Right. That's what's on
She emailed me, she goes, I reset yours. Which we know how to try again.
This one was new.
Georgie.
YouTube.
They give you a different week every week.
His original had.
You think so?
The inspiration map that you do.
Water tank.
It's
like 7 minutes long.
It doesn't say week one. I was just wondering if you give us 3 problems we're going to leave. Yeah, it's pretty good deal.
Larry picked up, I had
So maybe it'll take my very first year teaching.
I had his dog. And like 3 years later, I had his dog. And I could see him, I did so much.
But they're not all for sure.
I was one before I just wanted to search for information. That's the stuff I found. Yeah. I think the articles are really interesting. I also have links that
But since I have information, it's just a little bit more information I can find it. But in here, it's really a good problem.
I was trying to find a fourth grade class fraction, and it was my kids already
Is that your unlimited blog?
Thank you, Jennifer. Okay, I'm going to stop you guys. You'll have a little bit of time next Thursday, not a lot of time to work in your groups. I had a couple people ask me a few questions more about Dan Myers. And he was just a high school. How many of you have seen the TED Talk? I'm going to show it. So all I did to get to his TED Talk is I literally put in Google Dan Myers, and then the very first thing is his blog, and then you just scroll down a little way and you can find his TED Talk.
Oh my goodness.
My thesis is 200.
Can I ask you to please recall a time when you really loved something, a movie, an album, a song, or a book, and you recommended it wholeheartedly to someone you also really liked. And you anticipated that reaction, you waited for it, then came back, and the person hated it. So by way of introduction, that is the exact same state in which I spend every working day of the last 6 years. I teach high school math. I sell a product to a market that doesn't want it, but is forced by law to buy it. I mean, it's just a losing proposition. So there's a useful stereotype about students that I see, a useful stereotype about you all. I could give you guys Algebra 2 final exam, and I would expect no higher than a 25% pass rate. And both of these facts say less about you or my students than they do about what we call math education in the US today. To start with, I'd like to break math down into two categories. One is computation. This is the stuff you've forgotten. For example, factoring quadratics with leading coefficient greater than 1. Okay? This stuff is also really easy to relearn, provided that you have a really strong grounding in reasoning, math reasoning. We'll call it the application of math processes to the world around us. This is hard to teach. This is what we would love students to retain, even if they don't go into mathematical fields. This is also something that, the way we teach it in the US, all of it ensures they won't retain it. So I'd like to talk about why that is, why it's such a calamity for society, what we can do about it, and to close with why this is an amazing time to be a math teacher. Okay? So first, five symptoms that you're doing math reasoning wrong in your classroom. Okay? One is a lack of initiative. Your students don't self-start. You finish your lecture block and immediately you have 5 hands going up asking you to re-explain the entire thing at their desks. Students lack perseverance. They lack retention. You find yourself re-explaining concepts 3 months later, wholesale. There's an aversion to word problems, which describes 99% of my students, and then the other 1% are eagerly looking for the formula to apply in that situation.
Sound like your kids?
Okay. This is really destructive. David Milt, a creator of Deadwood and other amazing TV shows, has a really good description for this. He swore off creating contemporary drama, shows set in the present day, because he saw that when people fill their mind with 4 hours a day of, for example, 2.5 Men, no disrespect, It shapes the neural pathways, he said, in such a way that they expect simple problems. He called it an impatience with irresolution. You're impatient with things that don't resolve quickly. You expect sitcom-sized problems that wrap up in 22 minutes, 3 commercial breaks, and a laugh track. And
Or an objective that says by the end of the day,
already know that no problem we're solving is that simple. I'm very concerned about this because I'm going to retire in a world that my students will run. I'm doing bad things to my own future and well-being when I teach this way. I'm here to tell you that the way our textbooks, particularly math-adopted textbooks, teach math reasoning and patient problem solving, is functionally equivalent to turning on 2.5 Men and calling it a day. In all seriousness, here's an example from a physics textbook. It applies equally to math. Notice, first of all, here that you have exactly 3 pieces of information there, each of which will figure into a formula somewhere eventually, which the student will then compute. Okay? I believe in real life. And ask yourselves, what problem have you solved ever that was worth solving where you knew all of the given information in advance, where you didn't have a surplus of information and you had to filter it out, or you didn't have insufficient information and had to go find some? I'm sure we all agree that no problem we're solving is like that. And the textbook, I think, knows how it's hamstringing students, because watch this. This is the practice problem set. When it comes time to the actual problem set, you have problems like this right here, where we're just swapping out numbers and tweaking the context a little bit. And if the student still doesn't recognize the stamp this is molded from, it helpfully explains to you like what sample problem you can return to find the formula. Like you could literally, I mean this, pass this particular unit without knowing any physics, just knowing how to decode a textbook. That's a shame. So I can diagnose the problem a little more specifically in math. Here's a really cool problem. I like this. It's about defining steepness and slope using a ski lift. But what you have here is actually 4 separate layers. And I'm curious which of you can see the 4 separate layers, and particularly how when they're compressed together and presented to the student all at once, how that creates this impatient problem solving. I'll define them here. You have the visual, okay? You also have the mathematical structure, talking about grids, measurements, labels, points, axes, that sort of thing. You have sub-steps, which all lead to what we really want to talk about, which section is the steepest. So I hope you can see, I really hope you can see how what we're doing here is taking a compelling question, a compelling answer, but we're paving a smooth, straight path from one to the other and congratulating our students for how well they can step over the small cracks in the way. That's all we're doing here. So I want to put to you that if we can separate these in a different way and build them up with students, we can have everything we're looking for in terms of patient problem solving. So right here, I start with the visual, and I immediately ask the question, which section is the steepest? And this starts conversation, because the visual is created in such a way where you can defend 2 answers. So we get people arguing against each other, friend versus friend, in pairs, journaling, whatever. And then eventually we realize it's getting annoying to talk about the skier in the lower left-hand side of the screen, or the skier just above the midline. And we realize how great would it be if we just had some A, B, C, and D labels to talk about them more easily. And then as we start to define like what does steepness mean, we realize it'd be nice to have some measurements to really narrow it down specifically what that means. And then and only then we throw down that mathematical structure. The math serves the conversation doesn't serve the math. And at that point, I'll put it to you that 9 out of 10 classes are good to go on the whole slope steepness thing. But if you need to, your students can then develop those sub-steps together. Do you guys see how this right here compared to that, which one creates that patient problem solving, that math reasoning? It's been obvious in my practice to me. And I'll yield the floor here for a second to Einstein, who I believe has paid his dues. He talked about the formulation of problems being so incredibly important. And yet, in my practice, in the US here, we just give problems to students. We don't involve them in the formulations of the problem. So, 90% of what I do, my 5 hours of prep time per week, is to take fairly compelling elements of problems like this from my textbook and rebuild them in a way that supports math reasoning and patient problem solving. And here's how it works. I like this question. It's about a water tank. The question is, how long will it take you to fill it up, okay? First things first, we eliminate all the sub-steps. Students have to develop those. They have to formulate those. And then notice that all the information written on there is stuff you'll need. None of it's a distractor, so we lose that. Students need to decide, all right, well, does the height matter? Does the side length matter? Does the color of the valve matter? What matters here? It's such an underrepresented question in math curriculum. So now we have a water tank. How long will it take you to fill it up? And that's it. And because this is the 21st century, and we would love to talk about the real world on its own terms, not in terms of line art or clip art that you so often see, in textbooks, we go out and we take a picture of it. So now we have the real deal. How long will it take it to fill it up? And then even better is we take a video of someone filling it up. And it's filling up slowly, agonizingly slowly. It's tedious. Students are looking at their watches, rolling their eyes, and they're all wondering at some point or another, man, how long is it going to take to fill up? That's how you know you baited the hook, right? And that question off this right here is really fun for me, because like the intro, I teach kids, because of my inexperience, I teach the kids that are the most remedial, all right? And I got kids who will not join a conversation about math because there's, like, someone else has the formula. Someone else knows how to work the formula better than me, so I won't talk about it. But here, every student is on the level playing field of intuition. Like, everyone's filled something up with water before. So I get kids answering the question, how long will it take? I got kids who are mathematically and conversationally intimidated, joining the conversation. We put names on the board, attach them to guesses, and kids have bought in here. And then we follow the process I described. And the best part here, or one of the better parts, is that we don't get our answer from the answer key in the back of the teacher's edition. We instead just watch the end of the movie. And that's terrifying, all right? Because the theoretical models that always work out in the answer key in the back of the teacher's edition, like that's great, but it's scary to talk about sources of error when the theoretical does not match up with the practical. But those conversations have been so valuable, among the most valuable. So I'm here to report some really fun games with students who come pre-installed with these viruses day one of the class, okay? These are kids who now, one semester in, I can put something on the board, totally new, totally foreign, and they'll have a conversation about it for 3 or 4 minutes more than they would have at the start of the year, which is just so fun. We're no longer averse to word problems because we've redefined what a word problem is. We're no longer intimidated by math because we're slowly redefining what math is. This has been a lot of fun. I encourage math users I talk to use multimedia because it brings the real world into your classroom in high resolution and full color. To encourage student intuition for that level playing field. To ask the shortest question you possibly can and let those more specific questions come out in conversation. To let students build the problem, because Einstein said so. And to finally, in total, just be less helpful. Because the textbook is helping you in all the wrong ways. It's helping you, it's buying you out of your obligations for patient problem solving, and math reasoning, to be less helpful. And why this is an amazing time to be a math teacher right now, because we have the tools to create this high quality curriculum in our front pocket. It's ubiquitous and fairly cheap. And the tools to distribute it freely under open licenses has also never been cheaper or more ubiquitous. I put a video series on my blog not so long ago, and it got 6,000 views in 2 weeks. I get emails still from teachers in countries I've never visited saying, wow, yeah, we had a good conversation about that. Oh, and by the way, here's how I made your stuff better. Which, wow. I put this problem on my blog recently. You get in a grocery store, which line do you get into? The one that has 1 cart and 19 items, or the line with 4 carts and 3, 5, 2, and 1 items? And linear modeling involved in that, some good stuff in my classroom, but it eventually got me on Good Morning America a few weeks later, which is just bizarre, right? And from all of this, I can only conclude that people, not just students, are really hungry for this. Math makes sense of the world. Math is the vocabulary for your own intuition. So I just really encourage you, whatever your stake is in education, whether you're a student, parent, teacher, policymaker, whatever, just insist on better math curriculum. We need more patient problem solvers. Thank you.
So that's Dan. He's a California boy. That kind of launched him into, I don't know what you call it, stardom. He quit teaching and went back to Stanford to get his doctorate in curriculum design, and he just finished his doctoral, they call it a thesis? Dissertation. He just finished his dissertation this year, which he posted on his blog if you're interested in. I read about the first 2 pages. It's about 300 pages long. It's a little bit more than I want to read. But he also, right below the dissertation, he has a little video of himself describing what his dissertation is about, which is kind of cool. But his blog is awesome. Every time he gets to speak in front of people, he posts it up on his blog. His blog has got a wealth of information. But his big thing is that we are better instructors than that textbook that you have in front of you. Textbooks take away all the mystery of the coolness out of mathematics.
Boy, Carl, I just spoke to you on that. Can you say that one more time about our relationship to the textbook? One more time.
We teach, the textbook doesn't teach.
Oh, I'd like to have that repeated in black.
Your administrators know that. They know that you're good instructors. In the old system, we used to say fidelity to the program. All the way from the state now, they're saying a textbook is a resource. And I've heard that mantra in Clovis Unified too. Your textbook is your resource. You are the teacher. Your job is to make it better. Right? Last thing, I have a form for you where you're going to think about all the stuff we did this week and try to digest it in a way that you can write a letter to yourself about what you learned. You're going to turn that in, and then we're going to stick it in inner office mail back to you at some point during the year so you can read and see what you learned. So, you got it? Thank you. You won't need your computer at first, so you can shut it down.
TED Talk.
And they usually come in for
Administrators that push their teachers to teach curriculum fidelity are the ones that have lost faith in their teachers.
go by the standard. But it is a younger